has a very interesting and complex mechanisms to adapt to salinity. One of those is by having salt glands. Those glands store the excess of salt on the leaf surface. Another mechanism is by salt ion sequestration into the back walls inside the cells to avoid ion toxicity, to avoid that the plant gets intoxicated, and to ensure the normal functioning of the plant. And there are also many other mechanisms that are actually very complex, and until now there is not a clear knowledge of how these work and what are the reasons why different varieties have different strategies to cope with this. But in general, yeah, they can handle very well very high levels of salinity. So that's why in my work we wanted to try to improve our understanding of the salinity stress tolerance mechanisms that we see in quinoa by using a model, and also using this knowledge to improve soil salinity, to reduce soil salinity by adding some management practices. So the model that I used is called SWAP-WOFOST, that was developed in the Netherlands. And as you see, is a coupled model, like SWAP from one part and WOFOST the other. I will explain very briefly how it works. SWAP is a model that simulates the transport of water and solutes in the soil based on the weather conditions, the soil texture, the type of crop, groundwater, irrigation, etc. And it can take into account all of these and calculate the stress in the crop, meaning drought stress, salinity stress, oxygen stress, etc. And this stress is translated in a reduction in transpiration in the crop. And for the other side, the model WOFOST is the one that calculates the crop development according to this reduction in transpiration. And how salinity is taken into account in this model? Well, it uses a simple salinity stress function. As you see, that it's just a linear relationship. That it basically says that above a certain salinity threshold, in this case X max, the plant will start experiencing some stress according to that linear relationship. For example, if the soil salinity concentration is 10 milligrams per cubic centimeters, you will have, let's say, a 30% reduction in transpiration and in yield. Okay, so the field experimental data that we use here, it was from 1 year, 2021, and it was collected in the Layun area in Morocco. You see in the map, and this is a very dry area that they have a lot of problems of salinity. They rely heavily on irrigation, and it's also very hot. And they applied 3 salinity treatments. They irrigated with 3 salinity levels, low, medium, and high salinity, and they used the variety ICVA Q5 and a sandy loam soil, and for their experiments, they also apply some organic amendments that I did not consider in the model. Yeah, if you want to know more about this, there is a link there about this experiment. And what we could learn, first, by calibrating the model, we can see the different fluxes. For example, the evapotranspiration in red, the transpiration, and the irrigation. Leaching was very, very small, so we don't show here. And as you can see that more or less in the first month, when the crop hasn't grown much, basically all the water that is added by irrigation, which is the blue line, is lost by evaporation, the red line. This is the cumulative fluxes. So we see that there is an over-irrigation at the beginning of the season, when the plant doesn't need much, but they apply more or less the same amount of irrigation to ensure seed germination. But in this case, it's important to consider that apart from water, they are adding salts in the soil, which are not lost. I mean, if water evaporates, the salts remain in the soil. And this causes salt accumulation in the soil. As you see here, the bump there, that is during the growing season, you see that when the plant is small, the salts accumulate. But an interesting aspect of quinoa is that it's able to take up solutes, different to other crops like potato, maize, that they normally, won't be able to do that. They just leave the soils in the soil. But in this case, quinoa is able to take up solutes, and which is good. And we see that the model is able to simulate that decrease of soil salinity over the growing season because quinoa is taking up solutes. So that is also very interesting. And in terms of yield, we can see that, maybe I can show, sorry. Yeah, you can see that the highest yields, right, is the ones that have the lower salinity treatment. And there are not much difference between the low and medium salinity levels, which means that quinoa can handle very well up to medium salinity levels, but at very high salinity is already affected, but still the yield is pretty good. So that is important. And so coming back to the over-irrigation during the first month, we wanted to evaluate what we could do to solve this problem. So we evaluated 3 salinity management scenarios. One, we said, why if we just reduce irrigation during that first month, how that would affect the crop? And also, what if we add mulching? And there, what if we add mulching plus reduce irrigation? We can see here that this is the cumulative evaporation, which I said there, the evaporation is a lot during the first month. So we see that there is a reduction of evaporation, a high reduction in evaporation with the different management, especially by adding mulching. And in terms of yield, we can see, for example, in the yellow one is the one that performs better. And this is by adding mulching. And we can see that especially by the high salinity level, the one in the graph in the right, you can see that actually the yield increases quite a lot. And just by adding mulching, just by reducing the soil evaporation. But by simply reducing irrigation during the first month, we also can have some benefits already. So maybe this is something that farmers in this area under these conditions can really maybe use it, just try better irrigation management practices, or can add mulching, because that really allows to keep more water in the soil and to reduce salinity, that unnecessary salinity stress. So in conclusion, we saw that the simple salinity stress function that the model uses, the linear relationship that I showed, is able to incorporate the crucial salinity stress mechanisms shown in quinoa. Of course, it cannot incorporate all the complex mechanisms, but we saw, by comparing the observations with the simulations, that it's able to cope the most important ones. So that is a very important point, because we can use the model to assess other management practices to assess maybe how the quinoa will perform in the future and things like that. Also, that in this case, we saw that there is over-irrigation, and over-irrigation that causes unnecessary salinity stress, and that can be managed, but simply reducing irrigation during the first month by dry mulching and maybe other management as well. And yeah, to improve productivity under saline conditions. And that was my talk. Thank you very much.
Thank you very much, Ms. Diana. Just a remark, Layun is not Morocco. If you were there, you must have seen the Spanish flag over there. And there is a resolution of the United Nations asking Morocco to call for a referendum for autodetermination of the Saharian people. So this is just for your info.
Okay,
And
well,
any other question?
I don't know if they will agree.
Do you have questions? Yes, please. Take microphone, please. Come close to, because I think it's just one.
Yeah, thanks for your nice presentation. I just have a quick question about the mulching. Is that using plastic mulching or use the crop residue mulching for mulching treatments?
Which type of mulching you mentioned?
Yeah, right.
Yeah, since this was just a scenario, yeah, normally I think they use their organic mulching. So with the model, we try to simulate what mulching would do in terms of soil evaporation. So we focus on reduction in soil evaporation. And yeah, so that's what we did, but it's a scenario. So there is a potential there, but we don't have observations in that aspect. Yeah, so I don't know if that answers your question. Thank you.
So thank you very much, Ms. Diana.
There is another question.
I think that, yes, very quick one, because we are hurried up. And,
Yes, sure.
Yeah.
Thank you for your lovely presentation. I think I saw in a graph of the salt balance that it was your model was pretty good, pretty able to predict the salt balance. But I thought I saw it was much better at the highest and the lowest salinity level, much less of the 12 decisiemens. Do you have an explanation for that?
Not really, but I guess it's because, for example, the soil parameters were not calibrated. We just took one that could represent the sandy loam soil. So we saw that maybe, yeah, we could do some improvements there, but I guess it's because of that we didn't calibrate those parameters. Okay, thank you.
Thank you very much. Now we move to next speaker that will be online. Dr. Youssef Hasseminejad from the Soil and Water Research Department, Agricultural Natural Resource Research and Education Center, Agricultural Research, Education and Extension Organization in Mashhad, Iran. Dr. Hasseminejad, the floor is yours.
Thank you. Could you hear me? Hello, could you hear me?
Yes, we hear you well.
Yeah, and thank you very much, Mr. Chairman, ladies and gentlemen, and thank you for having me here. The topic of my presentation today is leaching.
Please put in the full screen your presentation.
Could you see my presentation on the screen?
Yes, but not in the full mode.
Yeah.
No, we cannot because he's making it from his side. I see.
Is it okay?
No. Now yes. Okay.
Now it's okay. Our apologies for the online participants. Sometimes there's technical issues. Please go ahead, Dr. Hasseminejad.
Oh, thank you. The topic of my presentation today is leaching or reclamation, which one matters. This topic is at least my mental challenge for affected soils of Iran during, I think, about 2 decades. All of us could remember from courses in the bachelor degree, I think that the management of saline sodic soils are quite different. here I want to say that reclamation of sodic soils is much easier than leaching of saline soils, especially when there is limitations in water allocation in arid regions. Most of salt-affected soils in Iran are irrigated ones. Salinity of irrigation water, which is mainly supplied from the deep groundwater, is the main factor for soil salinization, actually secondary soil salinization. These water resources generally suffer from elevated levels of EC and SAR. But in this paper, I will show you that the irrigated soils suffer from salinization only and not sodification. In order to evaluate the salt-affected soils in irrigated area, we have to evaluate the status of irrigation water and soil in the classification schemes. In this way, different guidelines are proposed and used in the international and by the international and domestic group of researchers. The implementation of these guidelines should be carried out with consideration to the assumptions and prerequisites of each one. By the advent of new problems and perspectives in utilization of salt-affected soils, there may be a necessity for rearranging available classifications. Some examples include the development of magnesium-affected soils and water resources, which is reported from Iran, Central Asia, and Pakistan, as reported by Qadir and his colleagues in 2018. Or development of desalinization plants for agricultural purposes, as reported by Rahimi. Recycling of drainage water in horticulture plants, as reported by Khorsandi and his colleagues. And environmental and non-agricultural use of saline water and soils for environmental issues, as reported by Salehi in 2020. Our study area is about 3,000 hectares of pistachio orchards in North Ardakan, Yazd province of Iran. This area is irrigated with about 125 well water resources, which were sampled and analyzed in the laboratory. Also, about 80 fields were selected for soil sampling down to 90 centimeter depth in 30 centimeter increments. The composition of saturated extract were sampled and measured in the laboratory. In these graphs, you can see the distribution of salinity and leaching requirement in the studied water resources. As you can see, about 25% of water resources in the left-hand side graph, about 25% of the water resources have salinity of less than 8 decisiemens per meter. You know that 8 decisiemens per meter is considered as the salinity tolerance threshold for pistachio. And about 25% of water resources have salinity of more than 14 decisiemens per meter, which is considered very high for pistachio. Generally, about 75% of irrigation water resources have salinities of more than the threshold of salinity for pistachio. Regarding to this salinity tolerance of pistachio and salinity of irrigation water, we can calculate the leaching requirement for each water source. And in the right-hand graph, you can see the calculated leaching requirement for these water resources. As you can see in this graph, about 25% of irrigation water sources need less than 15% leaching requirement, while about 25% of irrigation waters need more than 30% leaching requirement, and about 10% need leaching leaching requirements of more than 40%. In this graph, you can see the status of soils irrigated with these water resources. In this graph, you can see lines which are corresponding to the leaching fractions of 10%, 50% to 15% to 50%. In each line, the points are located, which are located below the line, have leaching fraction values of more than that line. For example, the lines which are located below the line of the points, the points which are located below the line of 10% have a higher leaching fraction of than 10%. And in this graph, you can see that many points are located below the line of leaching fraction of 25%. 25% leaching fraction is a standard, let's say standard leaching fraction, which is used in the salinity experiments. And 50% leaching fraction is very high, is considered very high, which leads to loss of a huge volume of water when applying this volume in agriculture. In these graphs, you can see the status of irrigation waters regarding to the risk of infiltration problem. You know that the infiltration problem in irrigation water resources should be considered both EC and SAO, or EC and cross index, as proposed in the new literature. In each case, you can see that the infiltration problem is not expected to develop in the area by irrigating with these water resources. All water samples in this area are located in the area of without infiltration problem. So in this under these conditions, we expect that applying reclamation practices could not improve soil infiltration, while the supplier of agricultural products are advertising within the farmers to sell them the products that are used for improving soil infiltration, while these soils do not need these products. In this graph also, you can see the status of magnesium to calcium ratio in irrigation water and soil resources in the studied area. Although there are some cases in the area which the magnesium to calcium ratio is more than even 3, but in soil samples studied in the area, almost all of soil samples have a magnesium to calcium ratio of less than 1. But this is an alarm to the producers in the area because water resources with high magnesium in the area is developing. And finally, about bicarbonate concentration, in this graph, you can see the status of cumulative probability percent of bicarbonate concentration in irrigation water. And as you can see, about 10% of irrigation water used for irrigation in the area have the concentration of higher than 6 milliequivalent per liter, which is considered to be high for plant, as it could have some negative effects on the fertility and nutrient concentration in availability in the soil. As a
Excuse me,
conclusion,
okay, great, 3 minutes. Go ahead, excuse me.
sorry?
I was warning you for 3 minutes still, but you are arriving to conclusion, so excuse me for the interruption.
Thank you. In conclusion, the problem of high salinity in the irrigation water and the build-up of salts in the root zone seems to be a main obstacle for the sustainability of pistachio production in the area. Although the farmers were successful in partially controlling soil salinity through leaching, but their leaching practices will waste considerable volume of water as deep percolation in LF values of higher than 30% as indicated by former studies in the area. Sodicity were not common among irrigation water and soil samples evaluated in this study. Based on analysis of literature, the chemical amendment which are common for reclamating sodic soils could not reduce the soil salinity or increase the efficiency of leaching practices. Magnesium and bicarbonate-induced soil and water resources are developing in the area, which need more detailed consideration to take on appropriate management practice. To conclude, in irrigated soils of Iran, leaching is much more important than reclamation of sodic soils. That's it, and thank you.
Thank you, Mr. Hassanejad, for your interesting presentation. And I recall to all participants online that you can make questions to be answered later through the chat, or if not in time here in the room, but can be moved this convey this questions to the speakers. Thank you very much, Dr. Hassanejad. And now I want to learn if Mr. Din Yankao is on the room. Next speaker. So we must jump over him to the next speaker is Mr. Pradeep Dey. Not here? Okay. So this Pradeep.
Hello.
So,
Hello.
Mr. Pradeep Dey?
Yes, please.
Yes, I think everything is
I'll
ready.
share.
Yes, and the floor is yours, please.
I'll share.
Put your presentation in
Yeah.
full screen, please.
Just 1 minute.
And you have 15 minutes. I will warn you for the 3 last one.
Joseph, can you stop sharing? Yusuf?
Mr. Pradeep?
That earlier one, if it is stop sharing, then only
Yes.
I can start actually. That's
Please,
why it is.
Dr. Hasemi Nejad, stop sharing your screen, please, because next speaker cannot.
It is still not unshared actually. Yeah, thank you. Thank you so much.
Please go ahead.
Is it visible, please?
Not yet. We just see your file browser.
It is not visible? From my side, actually, I'll share again.
Now,
Just 1 minute.
it will help you from here. So please ask for next slide every time you need. Your presentation now is
Just 1
on the
minute.
screen.
Yes,
Okay,
I think it will be done now. Is it visible, please?
Yes, we see introduction now.
Is it moving, please?
Now it is a problem of 4 hands on the issue. Now, okay, yes. And now we see the start. Yes, please.
So, okay. Honorable Chairman and all the delegates, this particular presentation, policy and legal framework for sustainable management of salt-affected soil. In fact, all our previous speaker, they have made somewhat easy by dealing with different aspects of technological aspect. So those are actually part of the any policy and legal framework that has to be done. So for brief introduction, actually salt-affected soil worldwide it is a problem, and that's why Glossalan has introduced this INSAS and this seminar today. The anthropogenic factor as well as geogenic factor. Geogenic, of course, it is in situ and it is there for so many years now. But with anthropogenic factors, particularly secondary salinization, climate change, these are main threats which is actually affecting soils. So existing regulations are mainly in line. Whatever I could scan from different literature of different countries, governments, existing regulations are in line with public trust doctrine rather than polluters pay principle or precautionary principle. Say if someone is has used some faulty practices and there is some secondary salinization, there is no provision of paying for that particular action, that is polluters pay principle or even precautionary principle. So it is mainly public trust doctrine based regulation. And then by crafting a comprehensive legal framework, we can ensure soil resource, safeguarding food security and promoting ecological balance that we will see. And effective policies must not, that should be a holistic thing, and it should not only address the reclamation and sustainable use of soil, but also should promote preventive measure and all future happening of secondary salinization type of problem and support affected communities also. So these are mainly 3 types I will say, but these are categorized more detail in so many literature. I am not going in detail, but saline soil, sporic soil and acid sulfate soil, particularly for those tracts where actually sea water inundation is there and jarosite and alunite, that type of minerals are there. But from management point of view, these can be mainly two, that is saline and sodic. Of course, there is another category that is saline sodic, but from management point of view, we think one is for this leaching and another is gypsum plus leaching. From that angle, there are two types. Then methodology for arriving at this policy and legal framework is mixed method approach where focus on focus on success stories, thematic analysis to identify key theme and relation, examining farming practices, technology adoption, all these things has to be was considered. Then consideration of barriers and enablers. There are some barriers and there are some enablers also. All those things are considered, we'll see those. And then development of policy and legal framework by monitoring and evaluation plan, what should be in place, stakeholder consideration, as well as some ethical consideration. Like one example is land degradation neutrality commitment of the government and SDG commitment of the government. Those things has also should be taken into consideration while formulating a robust legal and policy framework. So what are the technology solution? One is, of course, we have waterlogged saline soil where mainly subsurface drainage technology is used. This one, subsurface drainage technology. And then another one is for the sodic soil or alkali soil, that is gypsum technology, where we apply gypsum followed by there should be a bonding and then irrigation water is applied so that this is leached. And then there is a ready reckoner also based on this textural class. And you know, when there is more clay in the soil, then it is difficult and gypsum requirement will be more. That is the thing. So that's why this with the textural class for a particular type of pH2, this is, so for a particular pH, from that if we want to bring it down, we need more gypsum application in clay soil than in sandy soil, and in between loamy soil will be different. So this type of ready reckoners are also available and that can also be used. Then coastal saline soil, mainly land shipping technology, those are used. Then we have biodrainage, agroforestry and agar hole technique, where through biodrainage and agroforestry system, particularly where due to saline water, there is less pumping of water and ultimately that dilution of salt water is also possibility is less, and in that case there will be submersion. So it is a vicious cycle. If there is a salt water, then that will not be used for irrigation, then there will be less drag of groundwater, less chance of going rainwater and diluting that salty water, and with time water level will go up. So that for that type of situation, we can also use biodrainage or agroforestry. And then agar hole technique, particularly from PTO of a tractor, we can draw the energy and then we can plant the saltified soil. Actually, we break the calcium carbonate layer that we call canker layer, and then we can plant agroforestry. Then high RSC, SAR water, gypsum bed technology is used. And then rainwater recharge is also, this technology is used for management. Then another dimension is there, climate change. We have already, through climate change, high temperature in many places, with evaporation, this salinity, this salt affected soil, it is aggravated. Again, sea level rise. Because of this, due to climate change, again, due to sea level rise, there will be high EC or EC mainly in the sea level rise. And then this type of situation again needs further care. So climate change loss of soil organic carbon is also there, and we know that with the loss of soil organic carbon, dispersion will be much more aggravated in case of alkali soil. And in saline soil also, reclamation is again a difficulty. And then again for poor quality water due to climate change, again water quality further aggravated. So we have some reclamation oriented, conservation oriented and harmonized oriented practices. And we have this technology which can be superimposed with these financial and private practices like water user association, APOs and APCs, they can be brought for this reclamation process, and then research and advisory and extension umbrella that should be in place, and then policy and regulatory framework that will be overarching. So through this technology and through policy and networking overarching umbrella, we can manage actually saltified soil. These are the barriers and enablers that I was telling. R&D barrier mainly from top down to bottom up approach we need to follow. Then rigorous testing should be there. Rigorous testing based on GPS based mapping. Then socioeconomic barrier, financial capability, literacy, and this resolution of conflict. These are the situation which we can also use this type of enabler like doctrine of rational use, legal rights of water user association, financial plan of water user association, then dissemination barrier, know-how transfer, network and linkage and capacity building, and model for handling over drainage blocks. Then they here equitable distribution and water recharge and recovery. So this type of barriers and enablers, those has to be studied and then superimposed with the enablers for ultimately the delivery strategy of activity-based result-based scheme and sustainable land use plan. And this is a matrix of challenge solution matrix. We call it, that is soil salinity, secondary salinization through subsurface drainage, biodrainage, cover crop and residue, soil sordicity through gypsum technology, agar hole technology. Then we have through capacity building, we can solve this particular problem, specific iron toxicity, particularly boron, chlorine, and sodium, osmotic balance and tolerance crop. We have list of tolerance crop that we can address this particular problem. And then policy and institutional constant can be tackled through evidence-based policy making and advocacy. So through this type of challenge solution matrix, we can also zero in to our legal and policy framework. Then there are some non-technological components. This is very important to note that not only technological component, but non-technological components are also very, very important. Like land governance. So many SDGs are linked to land governance. So this is also very, very important, and local land governance practices are also very, very important. Extension and advisory services are also important. Then finance and market. We need some investment like 1,75,000 for subsurface drainage per hectare cost is involved. So how to get those finance, say some incentivizing those type of investment, and then marketing of different, say those particular companies who can provide the services. Those are also important. Local governance and cooperation. This is also very, very important, particularly SDG 16 and 5 are important here, and indigenous technological knowledge is also very, very important. And there are a lot of indigenous technological knowledge which can be used for superimposing our own technology and then refine it on the site and then apply. And this is the framework that I could arrive out after this, all this taking into solution matrix and this challenge and solution matrix, and then all the barriers and then enablers. This type of R&D solution through land governance, socioeconomic condition study, assessment of saltified soil, infrastructure, and resource availability. All these things along with R&D solution. So R&D solution can be, there can be 5, 6, say n number of solution. After of n number of solution, all these things should be superimposed with local infrastructure, local land governance, socioeconomic study, assessment of that particular land and resource availability. And then we can zero in, and then we can, through cooperation and implementation, we can apply. But before application, again, we have to see through this lens of SDG. Does it align with the SDG commitment of the nation of the particular area? If yes, then finalize the action, and through M&E, mentoring and evaluation, we can implement it. If no, then go back, and again, we have to ask for the solution. So this is basically what we have, I have also given over here. And we could see that sustainable management, then there should be a switch from doctrine of public trust to, may not be to the polluters pay principle. I would not like to suggest here, but doctrine of rational use, at least that type of thing we should aim, so that mitigating adverse impact, promotion of resilience, productivity, and environmental stability should be there. Holistic policy framework with scientific knowledge, technology, policy, and community engagement. These are the main theme. And then embracing sustainability is essential for safeguarding land, water, and future generation. So thank you very much. Thank you, INSAS, Glossaland, and FAO for giving this opportunity. And thank you, Chairman, and all delegates. Thank you very much.
Thank you very much, Dr. Pradeep Dey, for your interesting presentation and for keeping in time. Next speaker will be Dr. José Antonio Hernández. Yeah. Dr. Pradeep Dey, please stop sharing your presentation. So, and now we will give the floor to Dr. José Antonio Hernández from SEBAS, Consejo Superior de Investigaciones Científicas of Spain, that will present effect on halophyte based management in physiological, biochemical, and metabolomic responses of tomato plants under moderately saline conditions.
Okay, I think I have unshared, Chairman. Thank you so much.
Now, thank you, Dr. Pradeep. Now it is the floor for the next speaker. So, Dr. José Antonio Hernández, the floor is yours. Esperamos que te funcione. Si no, tienes que pero para derecha, izquierda, derecha, izquierda, eso es pasar.
Okay.
15 minutos.
Okay.
A los tres.
Vale, gracias. Thank you, good morning. I don't know you. Okay, first of all, I would like to thank the organizer for selecting this work as oral communication. This work is there about the effect of halophyte-based management in some physiological, biochemical, metabolomic response of tomato plants that grow under moderately saline condition. This work takes part of the, of the Halopharm project from Prima program, but also I would like to thank FESIC because this work is partially funded by the ICOP program for this institution. Okay. Okay, it is not necessary. I can read very well. That salinity is one of the environmental stress factors that limit the production. Okay, it's also one of the main responsible for land degradation. It is estimated that near 900 million hectares is affected by salinity, but that means that about 20% of the cultivable land is affected by salinity. In addition, it's also estimated that 1 million hectares per year is taken out of production owing to high salinity level. That means that 50% of the cultivable land will be lost at the middle of this century. At that time, will be about 10 billion people. Okay, if with the permission of the pandemic, we don't know. But it's people that we have to feed. So at that time, we will have less available soil, less water, but with more population, less soil dedicated to cultivation due to environmental conditions, including soil degradation, salinity, or the appearance of new pests. But just also to take in mind that not only salinity is the problem, because at the same time, salinity could be with another stress condition. Okay, there are different strategies we can implement to address this problem. For example, one of these can be to search for new, more salt-tolerant species or plants, including new rootstock. Search for new genetically modified plants. This is a strategy not allowed by European Union. To improve the efficiency of plants, for example, improving the performance of photosynthesis, for example, manipulating rubisco, photorespiration, among other pathways. In this case, probably using the CRISPR-Cas technology. Another possibility that you know is the use of halophyte plant as a remediator of salinity soil. You know, this plant very tolerant to salinity and water scarcity, also including the selection of halophyte-like clone, hyper-tolerant to sodium chloride, obtained by the in vitro technique. In addition, the use of an agronomic management, including the mixed cultivation, that means intercropping, or sequential cropping, or crop rotation. So salt-tolerant plants may provide an interesting alternative for many developing countries by using the so-called saline agriculture or biosaline agriculture. And the production in these salt-affected areas can contribute to soil restoration and or the protection of productive and natural resources affected by salinity and water scarcity. Also, help to improve also the plant biodiversity or soil biodiversity. Okay, this is well, we work in this project in a commercial greenhouse in cooperation with the company Coagula, the Farm Association FECAMUR. This is the demonstration center, La Pelica. This is placed in the southeast coast of Spain, Águilas. This is the facility we use this greenhouse. This is just a picture of our different management. We use tomato varieta Sargento provided by Coaguilas as a Trocalum macrostachium as the halophyte plants. This is the monoculture, intercropping, and sequential cropping. This is the experimental design, including the tomato monoculture, the cropping, and the sequential cropping. That means tomato in monoculture in a plot where previously were cultivated with halophyte plants. And this is not here. But we work in two different seasons. The first season, spring, summer season, with only monoculture, intercropping, and halophyte. And the next season, the autumn, winter, we include also the sequential cropping. So I'm going to focus in the rest of this second season because we have the three different management: monoculture, intercropping, and sequential cropping. In the case of macronutrient, because of the time limitation, I would like to focus in sodium, for example, because we found in this season an accumulation of sodium on leaves, both in intercropping and sequential cropping, but a decrease in sodium in the root. Finally, in the soil, the change was not significant, but there is a tendency to decrease sodium. Regarding to anion and focus on chloride, we observe an accumulation of chloride in leaves in all cases, but a different response in between intercropping and sequential cropping. There is an accumulation of chloride in intercropping, but a decrease in sequential cropping. Finally, this leads to a lower chloride content in soil by the intercropping and sequential cropping. Okay, we analyze also the sodium absorption ratio, but in this case, we see soil sample extracted by acid digestion, not a plastic extract. This is because just when we were writing this paper, the referee asked the data. At that time, we didn't have the soil sample, so we used the data of sodium, calcium, magnesium from the sample extracted by acid digestion. But anyway, we obtained the result. We observed a significant decrease in intercropping and also a significant in sequential cropping, but not statistically significant. Regarding the electric conductivity, we observe also a significant degree in sequential cropping that correlate with the lower chloride content we observe in the soil. Okay, we were also interested in the study, the effect of this halophyte basic crop management in the photosynthesis, but analyzing the different fluorescent chlorophyll parameters. Well, in general, we can see that the photosynthesis was okay in all cases. due that the F values was above 0.8. But interestingly, intercropping produced an increase in the non-photochemical quenching parameter. This was observed in the first season. That means that this increase is related with a mechanism of forcibly dissipating excess light energy, thus minimizing the reactive oxygen species produced in the chloroplast, thus offering a protection to the chloroplast under stress conditions. In addition, also, this plant have an increase in the electron transport rate. The lack of negative effect of salinity in photosynthesis means that probably this sodium, this is accumulating on leaf, doesn't not accumulate in the chloroplast, but the same with the chloride. Okay, we also studied this effect in crop management in the antioxidant metabolism. I explain also only the significant difference. For example, it's interesting that intercropping and sequential cropping produce a significant increase in this enzyme, ascorbate peroxidase. This is an hydrogen peroxide scavenging enzyme. But in addition, sequential cropping produce an increase in monodehydrascorbate reductase and glutathione reductase. That enzyme is related with ascorbate and glutathione recycling. In both cases, there's a decrease in this enzyme, the hydroascorbate reductase, also related with ascorbate recycling, but is interesting. Well, first, I'm going to explain you that plants have two different ways to recycle ascorbate. Let's see, the cheap one is monodehydrascorbate reductase that only need NDH reducing power. But the expensive one is the other way. The hydroascorbate reductase needs first glutathione as electron donor, that the glutathione is oxidized, and for the recycling, the plant needs another enzyme that need NDPH as electron donor. So ascorbato recycling via monodehydrascorbate reductase is energetically more efficient than the other way, the hydroascorbate reductase. That happens here if we add both activities. This is the total ascorbate recycling activity. There is a tendency in intercropping and sequential cropping to increase the percentage for using this enzyme and a decrease for the other way. Consequently, it can be suggested that intercropped sequential cropping plants use less energy to enzymatically recycle ascorbate. In addition, we did a stoichiochemical analysis in situ just to observe the accumulation of superoxide or hydrogen peroxide by studying with new MPT or the aminobenzidine. That we observe in general an accumulation of superoxide near the main ore vein, but worse, also hydrogen peroxide. This is this dark spot, but this was more evident under intercropping and sequential cropping. So this response, in addition with the increase in ascorbate peroxidase and this more efficient ascorbate recycling activity in tomato leaves from intercropping and sequential cropping crop management, suggests probably the establishment of a moderate and controlled oxidative stress that could be related with the adaptation mechanism. In relation to the production, in this season, we observed, in terms of kilograms of tomato per plant, only a significant increase in sequential cropping that was correlated with a higher number of fruit per plant. In relation to quality, the acidity, no change, but a significant decrease in the breeze degree. I will also to inform that in the first season, also intercropping produced more than the monoculture. In addition, we studied the metabolome of the plant by using the Mammichov algorithm. We compared the tomato intercropping versus tomato monoculture and the allophyte intercropping versus allophyte in monoculture. And we observed a different response because intercropping condition led to a stimulation of sugar and starch metabolism in tomato as observed by the change in metabolite related, for example, with ascorbate, galactose metabolism, starch and sucrose metabolism, among others. But in allophyte, intercropping mainly altered amino acid related pathway, as observed by change in metabolite related with arginine and proline metabolism, amino acid tRNA biosynthesis, or tryptophan metabolism. This is just to summarize the response of intercropping and sequential cropping in relation to monoculture on leaves, there is a common response in both cases. Accumulation of sodium, less heavy metal content, an increase in reactive oxygen species in both cases, and an increase in antioxidant enzyme, especially sequential cropping. In roots, you also an accumulation of heavy metal, an increase of chloride in intercropping, but a decrease in sequential cropping, and in relation to production, not change in production quality in intercropping, but higher production in sequential cropping. This is just also to show you, this is my last slide. It's a pity we can not see this. This is the Arthrocolum macrostachium line plant that we obtained by in vitro clone that was tolerant to 30 gram liters. Sodium chloride, that means the salinity in the Mediterranean Sea. And we compared this plant with the nursery plant. And this was only because we found a chameleon here masked with the plant in one of the, it's a pity we cannot see the chameleon. So again, thank you. You have some question?
Thank you very much, Dr. José Antonio Hernández. There are two questions. Could you please, somebody bring the microphone there? In the meanwhile, I have a question. It's true that these tomatoes are most tasty? Si están más sabrosos los tomates.
No, I'm sorry. We didn't make any panel for tasting. Or we taste directly at home, but all the tomato was nice.
Yes.
In fact, it was a variety selected by the farmer. So, in fact, was a very good variety. Estaba encendido, sí. Sí.
Pepe, nice talk. When you grow with the rotation, what do you do with the halophyte before, well, after it is grown? Do you harvest the halophyte and put it somewhere else, or do you incorporate it in the soil?
Yes, I explained. First, we the only monoculture intercropping and halophyte, and from the next season, in the plot we have halophyte, we eliminate the halophyte and we put the tomato in monoculture for crop rotation.
So when you eliminate, you remove the sodium to a different site. The
halophyte was eliminated.
But you take the halophyte residue and you place it another site.
No, in the same. We use the same greenhouse.
Okay.
We were dividing different plots. By in the next season we change, but we use the halophyte plot for tomato for the next season, just to have different repetition of the crop rotation.
Okay.
Thank you.
Any other question?
Sí.
I ask the next speaker to be ready.
Mi miedo es no entender la pregunta muchas veces. Que mi miedo es no entender la pregunta. ¿Le puedo contestar lo que quiero?
Can you hear me? Is it okay, or should I go?
Sí.
Yeah? Okay.
Yes.
So thank you very much for a very interesting talk. I agree that intercropping is very important system for cultivation in agriculture. But I think that it is worth to mention also about the microorganisms which can be used, for example, for inoculation. And I'm talking about bacteria, but also mycorrhizal fungi or endophytic fungi. But I would like to ask you if you, because you presented the results from intercropping, but do you know something about the microorganisms or microbiome of soil? Because this is very important, how, for example, endophytes of plants you use for your experiment interact with microorganisms or plants you plan to cultivate.
Okay. No, I know that is very important, the microbiota, as is important for us. But we are not expertise in soil science. So it was a thing that we was thinking just to take soil sample. In our institute, there is a group that works in this area, but sometimes they have no time for cooperation, But we are interested in the next project just to cooperate, for example, with you. We have good luck with the next project, and to send you samples of our soil just to study the microbiota. Yes, but we don't have information.
Just my simple question to you is if you plant a seed or if you use the seeds for your experiment or plant. So
No. Well, the plant was grown by seeds by the farmer, and then as soon as the
transfer to the
yes,
to the
yeah, this is a
so
transplant.
you
Yeah.
can see that the microbiome you transfer the microbiome from
Yes.
other sites.
Yes, we
So
plan for a nursery. Yes.
maybe the effect and maybe the most important.
Yes.
Not just to use two plants for intercropping.
Yeah, this is something that we don't have in our mind because we are not expertise in this area.
Thank you.
Yes, thank you. Thank you for your suggestion.
Thank you, Dr. Hernandez. And now we move to the next speaker. That is Dr. Olena Droz, that is online. Are you ready, Dr. Olena Droz?
Yes, I am ready.
Yes.
Just a minute, I'm trying to share my screen.
Yes, the floor is yours when you...
One moment, I can't find my presentation. Can you see my screen?
Yeah, she's...
Can you see my screen?
No, but maybe it's not your fault. Let's... Yes. Now, yes, start sharing, please.
Can you see my screen now?
Now, yes. Could you?
Yes.
Yes, please share in full screen.
Is it full now?
Yes, we see your presentation, but it is in working mode. So please move to the full screen. So it is F5.
I know this, but I can see it in full in my computer. I don't know what the problem is.
Try with the key F5.
F5. Can you see it full now?
No, but if you can run your presentation in this way, it is big enough to we can see the details. So please go ahead.
I'm so sorry. I don't know what the problem is, but I can see it.
This happens. This is more complex than expected. But please start with your presentation and pass the slides.
Thank you. Hello. Today I will present the common research with my Ukrainian colleagues who are now in Ukraine. It's a common research about the Ukrainian soil cover and the reason for salinization and because of drip irrigation. Please say if the slide is changed now. Hello? Is it another slide or a title one?
You click in the sidebar, second, it will come.
Second.
Please click in the sidebar, second one, it will come. The second one will come.
Okay, second one. Yes, it's second one.
Yes, yes.
Oh, okay, thank you. So the land use of Ukraine now in the slide, as you can see, the most of the part of the territory is agricultural lands, and most of them is croplands. The saline soils in Ukraine not very big amount, is nearly 7% among the croplands, but the main cause for spread of saline soils in Ukraine is arid climate, especially in the south region, salinity of the bedrock, and poor irrigation management. The assessment of the impact on climate change on the condition of natural moisture supply in Ukraine shows as a rising trend. As a result, effective farming without irrigation has become virtually impossible, especially in the south regions of Ukraine. The total area of irrigated soils in Ukraine is about 2 billion hectares, but about 506,000 of hectares are actually irrigated. Currently, the area under drip irrigation in Ukraine has increased widely. Soil cover in irrigated territories are represented by Chernozem, dark chestnut, and chestnut soils. Among these soils, all the types of Chernozem soils or black soils, they are not salt affected, but in the influence of poor irrigation practices, it can be salt affected. That's why this problem. Vegetable production in Ukraine using drip irrigation is concentrated in small private farms and land holdings. Very often farmers don't have special knowledge and education and don't realize the consequences of such actions. This is also one of the reasons for degradation on Chernozems out under irrigation. These soils often not included in the state monitoring system. This makes it difficult to accurately determine the area and current ecological and agromeliorative conditions, and therefore affect the objectivity of data on the actual spread of irrigation degradation process. That's why the object of our scientific research was the southern Chernozem. It's not salt affected in the beginning. For irrigation in the main causes of soil degradation under drip irrigation is exceeding technological irrigation limits, poor quality of irrigation water, use of drip irrigation on previously irrigated soils with varying levels of irrigation degradation, mineralized unconfined groundwater, and salt content in bedrock. For irrigation in our country, we use both surface water and groundwater in some cases, especially if it's we are talking about private farmers. That's why sometimes it's water not suitable for irrigation. According to national state standard, this water which we will research has a second level of quality. It's not very suitable for irrigation. And as you can see, the parameters of southern Chernozems indicate that it's not saline. It's very important to pay your attention that for estimation the level of irrigation degradation in Ukraine, we have also a national state standard. And according to this standard, to estimate the salinity, the average number of points per 1 kilometer should be from 6 to 10 points. But for local moisture causes, special differentiation of soil parameters is in chain irrigation tape, crop row, boundary, and moisture contour, row spacing is not included. That's why we propose another scheme for soil sampling. Local accumulation of salt in the soils can reach significant, and in some cases classification significant. In each monitoring site, a soil sample is taken directly under the tape placement, in the crop row area, in the area of moisture contour boundary, and in the non-irrigated row spacing in each 25 centimeter. The distance between the point depends on the crop grown, the granulometric composition of the soil, and the volume of irrigation water. Therefore, those parameters are set on a field-by-field basis. Here there are some results. We investigated the soil cover in a small farming places with a different groundwater level. In this picture, you can see the condition of groundwater table up to 2 meters. Unfortunately, in some cases, it's also used for irrigation. And the groundwater is predominantly of sodium, magnesium, composition with a salinity of 2.53 gram per liter. In soils with a groundwater table under drip irrigation, periodic soil flooding may occur as a result of exceeding the recommended irrigation rates. Visually, there is no strip process on salinization in a surface layer. This is a connection of contours with when irrigation rates are exceeded. The content of water-soluble soils can be not very high level in the high part of the soil profile, but we can see it's significantly decreased in the down layers. The most problem for these territories is exchangeable potassium and sodium ions. And as you can see, the main part of them are concentrated on the boundary of the soil moisture contour. If we are talking about the groundwater table of 3 to 5 meter, at the boundary moisture contour is increasing the content of toxic salt, especially because of chloride increasing by 3 to 5 times and the water-soluble sodium by 1.52 times. In the interrow, the upper part of the soil profile is insalate. The content of toxic salt gradually decreases with depth. In upper layer, in the zone of the irrigation tape and in the crop row, the content of exchangeable sodium and potassium is nearly 5%. At the boundary moisture contour, an increasing on the content is absorbed potassium and sodium is nearly 7% in some cases. So under the drip irrigation, is maximum of concentration of water-soluble salts was in the boundary or the moisture contour. The problem is typical for places with vegetable crops. The moisture zone doesn't correspond to the same one every year. That's why mechanical mixing of the soil in the moisture zone and the row spacing during post-irrigation tillage cause leveling on the strip halogenization only in the upper soil layer. In the deeper horizons, degradation change remains stable over the long period of soils use and trend to spread thoroughly. Methods of soil sampling for monitoring and assessment current state and mapping soil salinity under dripping irrigation is essential. It's shown that the variation of soil parameters is quite high. The variability of soil parameters in the chain irrigation tape, crop row, moisture contour boundary, row spacing was demonstrated. This variability cannot be detached using other sampling schemes under the drip irrigation, so the final level of salinization will depend on the prevailing in moisture contour in the different zones. Thank you for your attention.
Thank you, Dr. Olena Droz, for your presentation. And I think that questions can be forwarded to the speakers, if any, in the chat. And now, well, I'm happy. Professor Artemi took 10 minutes from the session for important announcements, but we are just 2 minutes over the schedule. So the session is finished. Thank you, all the speakers.
We have a problem with the Galadin because I reserved a restaurant that will be for us only, and we are only 20. They requested to be 40. Then if we are not 40, we cannot take the Galadin. No, at least not there. Okay? I will try to react and to find another place, but right now we just cannot offer us kind of special. Can we go for the lunch now? It's okay. Okay? Sure. Remember to pick up all your materials, all your computers, everything. The room is because you never know.
Good afternoon, ladies and gentlemen. We're slowly resuming after lunch here in Spain, Valencia. So while some participants are still coming back with their dessert or without the dessert, we will slowly start as we have also participants joining online with different time zones. So first, I would like to welcome Mr. Flavio Rodrigues do Nascimento from Federal University of Ceará, Brazil, who will tell us more about mapping environmental vulnerability to soil salinization in a semi-arid river basin in Brazil. Mr. Rodrigues, please, the floor is yours.
Okay. Hi, Maria. Good afternoon. Can you hear me?
Yes, we can hear you very well.
Yes.
Okay. Okay. So I share my presentation.
Yes, we can see it loading. And
Okay.
now we need to go to the full presentation mode.
Okay, okay, a minute. Just a minute, please.
So we cannot see it in the presentation mode yet. Usually there's an option to click at the bottom of the PowerPoint. There's a little presenting icon.
I'm trying. A minute. Just a minute, please.
Yes, of course.
Okay, now?
No, we still cannot see it in the presentation mode. Perhaps if you stop sharing and share again. Okay, now it's off. Okay, now it's loading and it's perfect. It's in the presentation mode. Thank you very much. And the floor is yours.
Great, great. It's a pleasure to be here again. Thank you, Maria. So, my work about affected solvers. I'm sorry. My work is mapping environment and vulnerability to soil salinization in semi-arid river basin in Brazil. And my name is Flávio Rodrigues do Nascimento. I'm professor at UFC, Federal University of Ceará in Brazil, northeast of Brazil. And the other authors are Joselita Castro and Antonio Santos. Let's start. So introduction, a brief introduction. Overview about this question. Soil degradation in the Brazilian region semi-arid, about 30% of salinization. It's a very, very propagated. And then we have several consequences, whereas a consequence is reduction in agricultural production and the migratory process, territory conflicts over land use, and the degradation of lands in general. And the other case, the expansion of salinization in Brazil, increasing the number of students. It's great. Lack of method there. Large set environments variables and social variables, and I'm sorry, my microphone. Large set of environmental variables, social variables. It's very important. About the objective, map the areas susceptible to soil salinization in river basin in Brazil, region semi-arid, and assess to vulnerability of local rural populations. So this is an overview from the map, location of the study area in specific. It's a sub-basin of São Francisco River. São Francisco River is a big river in Brazil, in northeastern Brazil. So predominant land use, rainfall and irrigation agriculture, semi-arid, climate semi-arid, rainfall it's is low, around the 780 millions in the year. It's very, very low, no? Map environment susceptibility to salinization, made in six attributes. First attribute, mapping of land use and cover. Second, the map of the landform, storing 4, 50, and 6, mapping the geological structure, mapping of evapotranspiration, mapping of soils, and the finished river channels and water. The methodology considers the crossing these parameters to make a synthesis. In the case, step 2 is specific, maybe social vulnerability to salinization, attribute access to information in the rural training, plus attribute economic, plus attribute access to infrastructure, maybe social vulnerability to salinization with a result. Step 3, crossing susceptibility to salinization with the social vulnerability in the expression, and about the results for discussion. Overview about the maps. We have different maps. In different maps, we have crossing attributes, different attributes about lithology, climate and the weather, slopes, let me see, soils, land use. In this case, to see a map with light green to red, with different situations about to susceptibility to salinization. Observe noting specific along the river with red, it's very prevalent, the case. And the principal results average to slow susceptibility with influence of soils and the areas not yet irrigated. Irrigated is perpetuated in the area. Very high susceptibility with influence of the channels along the channels with small irrigated areas. In this case, social vulnerability of the local population to salinization. Light green in the central map. Height very low, very low. Social vulnerability of the local population to salinization with result yes. The same legends, light green to red. Again, along the river, can you see red ponts and the areas in red? And low vulnerability, influence of areas with low susceptibility to salinization, and the high and very high vulnerability, influence areas susceptible to salinization, reduce access to information guidance for land management. In conclusion, in the study area, the environment's most conducive to salinization are those where the relief characteristics coincide, preventing water accumulation in the shallow water tables, and also as we dams are located, then it's important tool to analyze. With areas of agriculture producers for the local population, whereas they have soils with greater water absorption and less snowness. It's a reference, and I finish here. Thank you very much. I'm sorry for my microphone.
Thank you very much. Also, thank you for the great time management. I see some people clapping here.
Okay.
Thank you. And now we would like to ask for the questions. Any questions in the room? If there are no questions in the room, then I would like to ask one. Which aspect of the social vulnerability do you consider most important?
I think is a condition of socioeconomic conditions, because in semi-arid in Brazil, the population in semi-arid in specific, the population is poor, has a difficult to maintain agriculture, to maintain their houses. It's very common to make familiar work. So I think is the principal problem about this is a difficult socioeconomic difficult.
Yes, thank you very much. This indeed seems to be a difficult factor to take into account, and also for people suffering. Thank you very much for your presentation. We will now proceed to the next speaker.
Okay, thank you very much.
Thank you.
See you.
And our next speaker is a person joining here from the site. I'm just looking in the room and I think she's still having her dessert. So we need to go and chase her from downstairs. Let me see what is perhaps the best way to proceed.
I'm sorry.
Okay, then we will proceed. Oh, I see Julia approaching. If I see Julia approaching, let's see. Yes, okay, that's perfect timing because we are now coming to the presentation of Julia Mozo. Yes, now, so it's a perfect timing. So Miss Julia Mozo from the Department of Agriculture, Food, Environment and Forestry in University of Florence, Italy. She will tell us more about expanding food options through Tetragonia tetragonides, a solution to soil salinization challenges. I think yes, okay, great. The presentation, it's loading.
Here they want.
Yeah.
They are ordered by the
yeah.
surname.
Yeah, okay. And we're just loading the presentation. Oh, first need to share it or?
Here.
Yeah. Okay. All right, Ms. Mozo, the floor is yours.
Hello, I'm Julia from the University of Florence. And in this study, we try to find a solution to adaptation to the soil salinization challenges. We try to introduce a new species in our diet, that in this case, it's an halophyte, and it's the Tetragonia tetragonioides. So, oh, sorry. So the plant was selected in the salad project to assess the productive performance of these plants, the physiological response to stress salinity, and if the can we have a market in the whole country where these plants is not so well known. So the Tetragonia is from the Azoaceae family and is from New Zealand, Australia, and all the Pacific Islands. And was spread across all the other the continent and is already known and consumed worldwide in countries such as Japan, Argentina, China, Portugal also, and is a plant that lives in several conditions. So with a high tolerance to drought and salinity. So when it is in a contact out of the natural habitat, it can be severely penalized. But when it finds the perfect condition, such as coastline, dune, cliffs, and salt marsh, can be grows rapidly. Oh my God. Okay, can grows rapidly and has almost no competitors. So this is why it's not also for the invasive potential. So it's an includer halophyte. That means that uptake the salt from the soil and it's stocked in this specific epidermal structure called bladder cells, and where these plants accumulate the excess of salt that also help to the osmotic regulation and can also reduce the stomatal activity and evapotranspiration to deal with the stress condition. The edible part of this plant are the leaves, so where the more of the bladder cells are located. So if we look at the nutritional profile of these plants, we find out that is rich in vitamin A, B1, B2, C, have low fat and high fiber content, and also high level of oxalate. So, but we can easily deal with that cooking these leaves. So we can reduce the concentration of salt just steaming or boiling it. And from our previous trial and experiment, we found out, of course, as we expected, the higher concentration of salt, of iron, sorry, in the leaves, with the highest, with the increasing concentration of salt in the treatment. So we used 100 millimolar sodium chloride and 200 millimolar. No variation was observed for the potassium and for other important ions such as phosphorus, iron, and zinc. So how we already seen it already consumed in so many countries. But if we want to reach the upscaling that we want to for these plants, we have to investigate how it's perceived from from the market here. So we perform a taste test. This is how we grow our tetragonia in an hydroponic system with the 100 millimolar sodium chloride concentration. That is, we found out that is the salinity threshold of these species, where the performance are the highest. And after 3 months from the sowing, we start harvesting, and we keep harvest to every 2 weeks for the next 3 months until the mid-March, when we perform the last harvest. And we washed and froze the leaves directly after the harvesting. So the cooking method that was used to the test was that the frozen leaves were steamed for 5 minutes, and the portion was 15 grams per person, with just seasoned with a drizzle of oil, and was served with a glass of water at room temperature. So for each participant, a questionnaire was given to them that was divided in 3 parts. The general information about the testers, such as age, nationality, and gender. The second part was try to evaluate the sensory experience of the testers. So the overall rating, the color, the aspect, the smell, the taste was asking through an anhedonic scale from 1 to 9. And the last part was a multiple choice question to assess the tester willingness to purchase this product if it was an option at the supermarket. So if they prefer this species, this product over other dark greens that we already found in the supermarket, if the price were the same, if the price were lower, or even higher. And also the behavior that they will have if they were aware about the less impact that this product can have in the environment. So the panel was composed with 125 participants with an age range between 18 to 80. More female was present from 20 different nationalities. And the sensory evaluation, the results show how the characteristic that reach the more points were the taste, the aspect, and the texture. In the overall rating, more than 51% of the people react to a point of 7 and even more. So, but had the question, how do you find the test? So what's salty? The 13% replies too much salty for them. Just the 25% replies that was too little. And the 48% replies that was just perfect. But they will pay for that. They will prefer over other dark greens, over other dark greens. The 21% say no. Other 21% say only if this product is cheaper than the other vegetables. The 30% say yes, but just if the price is the same. And only the 12% replies yes, even it's more expensive. But when the people were aware about the less impact that these species can have in the environment, the people that willing to pay even more increased to from 12 to 38%. So oh, okay. So these are some recipes that we can already find in internet that show how these species can be versatile and can be used as other vegetables that we already used in our diet, like normal spinach. But as Tester said, it can be more tasty and crunchy. Thank you.
Thank you very much for this presentation and also showing the tasty dishes at the end. I think we now all feel inspired. So I would like to welcome questions for Ms. Julia. Any questions from the room? Yes, I see 2 questions. Perhaps let me share the microphone.
Okay, thank you very much.
Thank you.
Madam, for your very good presentation.
Thank you.
Yeah, I have 2 questions. The first one, can you tell me a bit about the fat and the fiber contents?
Oh, yes.
Okay. Yeah, fat and the fiber contents. That is very important when it comes to the vegetables.
Okay, I don't have the percentage, but it's compared to other vegetables like normal spinach or even over other dark greens.
Okay. Yeah, the second one is about immaturity. It takes how many weeks to mature? And I think that one could be the aspect of consumers and the farmers.
Oh, sorry, I don't understand. Can you repeat the question?
The maturity, how it takes long to grow.
To grow, okay.
Until
We
harvest.
sowed and we start harvesting after 3 months, more or less. But we kept harvesting for more than 3 months, and we couldn't keep going because it's not annual plants. So
Okay, I think another thing you can check about the perishability, how long it will stay on. Thank you.
Thank you.
Yeah, just comment about or question about the micronutrient analysis or other metal analysis. If Maria, you can go back to the slide. Yes, here. It looked like these are quite hyperaccumulators for metals.
Yeah, for sure.
And don't you think it can cause also some metal toxicity for the people who will be eating?
Yeah, of course, you have to take in count where you grow these plants. So of course, like other plants, you have to deal with the soil where you grow it. But of course, it's an accumulation plants. So yes, of course, we have to.
It's amazing that it has reached 900 ppm for iron in solution.
Yeah.
So it's quite a lot. Much more a lot. Yeah. So
thank you for the question.
Thank you very much for questions and comments. Important discussion I see here also about the uptake of heavy metals. Great. I've just got a comment from Maria that our keynote speaker that had problems with electricity is now back with us, and we have people coming back from the lunch. So this is a perfect moment to give the floor to Ms. Bilkes-Goul. Bilkes, can you hear us?
Yeah, can you hear me?
We can hear you very softly. Could you please say something again?
All right. Can you hear me right now?
Yes, now it works. Great. So welcome, and the floor is yours. We will be speaking about managing soil salinity in the Thar Desert through innovative cropping systems. Thank you so much for joining us, and welcome.
Thank you. Good evening, good afternoon, everyone. And I would like to thank INSAS and Sustain for giving me opportunity to discuss my research work. I'm sorry I cannot open the camera right now due to the poor internet connection. So I hope it will be okay. Today, the topic of my presentation is managing soil salinity in the Third Desert through innovative cropping system. As we all that soil salinity is significant issue affecting agriculture productivity all over the world, and salinity can reduce soil fertility and crop yields. And according to 2021 FAO map, it's around 833 million hectares salt-affected land based on 73% area map. So majority is only slightly to moderately saline. And according to United Nations report, it's around 110 countries exposed to desertification and land degradation, 1.3 billion trapped to on degrading agricultural land, 12 million hectares productive land become barren, 20% of our dry land. So world contain an estimated about 1,400 million cubic kilometer of water, fresh water resources, and only 0.003% of this amount, almost 45,000 cubic kilometers of our fresh water resources. I'm sorry, it's not. Slide is not.
It's not moving, and you would like to move forward?
Slide is not. Oh, yeah, I don't know what happened. It's,
if you click on your own presentation, okay.
Oh, okay, all right. Salinization can be noticed visually by analyzing the soil surface, the white crust on the, any soil surface or any land. And the salinization related indication on, especially on plants. So mostly plants withering, crop loss, reduction of biodiversity, and there's so many other morphological features that can show that the crop or plant is facing some stress, some kind of stress or salt stress. So there are several techniques to tackle salinization and improve agricultural productivity. One of the, I think, best option is to plant salt-tolerant crops to manage economic risk and ensure land cover. So I'm discussing the best available option, how to overcome the salinity problem, or how to use the degraded saline land for the agricultural purpose. So due to the increasing salinity and decreasing freshwater resources, so what is the best available option to overcome these problems? I think best available option is to grow halophyte plants. Halophytes are the only group of plants which could survive in saline condition and produce considerable biomass. So using halophyte plants and degraded land, basically utilizing saline lands or saline or brackish water for growing halophyte plants or those plants of economic importance is due to reduce pressure on fertile or agricultural land and good quality or freshwater resources. So I will discuss here one of my research project, biosaline agriculture project of fodder plantation at Third Desert of Pakistan, that is funded by Pakistan Science Foundation. And so basically Thar means desert. Thar Desert is one of the largest deserts of Pakistan, and Thar is situated in the province of Sindh, where I'm living. Province of Sindh, Pakistan. So Thar Desert is world's 17th largest and 10th largest subtropical desert, also known as the Great Indian Desert. And the climate of this region is because Thar is a subtropical area, and April, May, and June are the hottest month, and during that time, the maximum temperature will be, more than 50 degrees Celsius, average temperature, and minimum temperature is around 30 or 32. December, January, and February are coldest months. Rainfall vary from year to year, and mostly monsoon month rainfall occurs, and June and September are the monsoon months. So winter rains are rare. However, it has increased in the past 2 to 3 years, maybe due to the climate change. Freshwater sources are very rare. So water is scarce. I'm talking about the freshwater resources. So whatever seasonal rainfall is collected in tanks and reservoir is used for drinking and domestic purposes. So it's around 200,000 families, more than 200,000 families living in the third desert region have left their home due to the drought. And it continues due to the climate change. So availability of food and fodder. So most of the Thari people are dying because of the shortage of clean water and food. So Thari people have shown remarkable resilience in the face of adversity. They depend on their livestock as they cannot grow seasonal crops due to water unavailability. So livestock is the only means of sustainability for them. And a large number of livestock have also perished due to the severe climatic conditions. So the aim of my project, the objective of my project is turning Thar Desert into pasture for cattle fodder. So this is the project title. Project rationale is, as I told you before, that Thari people are really very poor, and they live on aquaculture and traditional agriculture cultivation. However, only a small number of crops can be planted during the monsoon season. And meanwhile, a large amount of salt is produced in the local coal mining process. I will tell you one thing. The demonstration site of this project is located near the coal mining area, Srinangro coal mining area. So most of the water is underground water is brackish or saline. Therefore, the best choice to improve agriculture production and ecological environment in this area, developing saltwater agriculture. So objective is introduction, adaptability, assessment of salt-tolerant economic plans for the Thar Desert, research on high-yield planting technology of salt-tolerant plants using salt water or brackish water, and development and utilization of salt-tolerant economic plants. And in this project, we are using a cropping system in which salt-tolerant fodder grass, Panicum antidotal, and salt-tolerant halophyte, Sweda, is using in this system. So Panicum antidotal is a perennial grass and distributed in salt-affected areas. And the other plant, Panicum is a salt excluder. The plant attain a height of about 1 meter in 25 to 30 days in summer. But in winter, it requires 35 to 40 days for comparable growth. So the basic model of my cropping system is here. You can see that Panicum, this is the grass, salt-tolerant grass Panicum, growing inside of the plot and surrounded by highly salt-tolerant, salt-absorbing halophyte, Sweda fruticosa. You can see here, we used a drip irrigation system in this field. Saline, the soil is highly saline, degraded, and we use saline water for irrigation, and this is a salt-tolerant plant. I will show you some pictures. Here you can see the barren land, and initially when we started the plantation, here is in this table you can see the chemical composition of the Panicum and the ZMAs. In this table, I will just show you or given such an idea what is the difference between a Panicum salt-tolerant grass when we compare to a conventional crop, ZMA. So most you can see that the ash, fruit fiber, carbohydrate, and other chemical compositions are as good as ZMAs. So we have done complete chemical analysis of this plant. Animal feeding trial experiments are under trial, and it's not done yet. I will show you some pictures of the field. Here you can see that this is Panicum during harvest time. So there are different experiments that we are doing in this research. Actually, plantation of Panicum, and the other experiment is intercropping of halophytes with the conventional crop. And as you know that the intercropping is innovative agriculture practices to improve crop yields. Intercropping experiments are under trial. So I will show you some pictures. You can see. So intercropping with some crop plants and some other wild plants. So there one other kind of aspect, soil amendment experiments. We are also working on the different soil amendment experiments right now. So conducting soil amendment experiment in the field and as well as in the greenhouse condition involve testing different materials and practices to improve soil quality and crop performance. So end user of this project is the local farmers owning land in the third region will be the ultimate end user of the outcome of this project. And Sin Agro Coal Mining Company will also be one of the beneficiaries, as this project will help in the utilization of salty water produced during mining process. And one of the important aspect of this project is training local farmers on biosaline agriculture, as well as soil amendment practices can significantly improve their agriculture productivity and sustainability. So here I will show you. The conclusion is that halophyte cultivation on saline soil using saline brackish water irrigation can be useful in combating both desertification and food scarcity. And we believe that the combined growth of panicum, the salt-tolerant grass, and the other plants, as well as some other crop and halophyte plant, along with the frequent irrigation with brackish water, will we will use brackish water obtained from underground saline water pump that is around 180 meters from the Penpit coal mine. So we are confident that the success of this project will bring a paradigm shift to the entire agriculture and livestock landscape of the Tharparkar region, making drought an irrelevant phenomena and bringing a green revolution to Tharparkar and nearby areas. So we believe that we have a mechanism for growing a halophyte grass for feed that, if properly implemented, could significantly utilize currently unused saline land and provide fodder to arid areas with abundant saline water resources. Thank you.
Thank you very much, Bilquis, for this interesting presentation and showing us the situation in Pakistan. This is a very insightful presentation for the people present here in the room and online as well. Due to the time constraints, we unfortunately cannot take any questions, but I would encourage people to type them in the chat and also reach to you for the email if any questions arise.
Yeah, sure.
Thank you very much once again for joining us. And we will be now proceeding to the next speaker. I would like to invite Mr. Turgay Dindaroglu from Karadeniz Technical University in Turkey. Mr. Turgay will talk about projects, policies, and actions in sustainable use of saline soils in Turkey. Let me also enable the presentation.
Hello. Hello. Good afternoon. My name is Turgay Dindaroglu from Karadeniz Technical University, Turkey. We prepared this presentation with my colleague, Özkan Elmas from Mehmet Akif Ersoy University from Turkey. I would like to give us some information about project policies and actions in the sustainable use of saline soils in Turkey.
At the right side, you can see our unique salt lake in Turkey, also in mid-Anatolia. And you can see the some change in the some season and many years, spatial and timeline change. And you can see the change in a dramatic also change we will see during the years also. And the soil depths are very changeable from the 40 centimeters to 1 meter. The left side, you can see the spatial distribution of the salted area in Turkey. And the red colors is the very salted, extremely salted area. And the yellow colors is the very critic regions also. Maybe in, I think, maybe in later some decades, this yellow colors area will be turn red color. Also, 1.5 million hectares are affected by salinity and alkalinity in Turkey. And around 3 million hectares have drainage problems also. And totally around 30% of irrigible lands in Turkey face issues with salinity, alkalinity, and drainage area. Of course, we have many phytoclimatic area, and but generally, the cause of salinity a big percentage is causes pan material, and then topography, excessive irrigation, land drainage conditions, irrigation water quality also, and the improper land soil management practices, or monoculture farming also. Our largest area affected by salinity, Turkey, is located Konya Basin, also located in the Salt Lake Basin in Turkey. You can see the salt produced in Salt Lake and in the video. We have some challenge for managing salted area, and first of all, we have challenge for soil degradation, water management also. We have crop selection to identifying and promoting salt-tolerant crops also, and maybe we have to use more technical expertise. Also, we have to monitor environmental impact also. It's a very crucial and not easy to challenge this problem. Also, especially finally, we come back to climate change. Best practice in salted area management. Also, we have many projects. I will give you some information next slide. Improving drainage area, salted tolerant crop selection, improving soil structure. Also, the four is very important. Preserve natural ecosystem. You can see at the right side in the video. We have flamingos. Around 20 million flamingos every year nested in this area, in the Salt Lake. Also, not just flamingos, but other also you can see the names. Many also you can see the figures, animals also incubate area in some part of the Salt Lake. We conserve this area also, protect this area. You can see the flamingos, and every year 20 million flamingos and comes there and incubated and then it goes. We have many projects also carried out as agricultural irrigation and land reclamation working group in Turkey, groundwater chains, forage crops in southern soils, and soil salinity distribution research. And my colleague also Professor Özkan conducted the International Multi-Collaboration PRIMA project. You can see some figures called hollow sheep agricultural sheep goat production system being carried out in investigation the utilization of halophyte plants grown in southern soil through the animal consumption. And also we have submitted, my team submitted some Horizon project, new in the April, agroecological accelerator at the landscape level, focused on keep soil health, including combat desertification, salinization, acidification, and also wrong land use. Let's see, we will wait results. And the policy, and we have also framework. It's a LOVE framework and 5403 LOVE number we have. This LOVE especially focused on conversation of soil, water, and plant. But we have also some detailed regulation combat or remediation of salted area. And this is maybe it's a common practices, also stakeholder collaboration. We have very lack of something in Turkey. We have to improve stakeholder collaboration and integrate. We use the watershed management plan in combat remediation of saline soils. So need to collaborate others discipline. Knowledge exchange also we use technical assistance also. We need to building capacity to farmers, land managers, agricultural extension services. Research and innovation, we try to give some project also, and we need to incorporate international laws or policy. The monitoring and evaluation is very important. We use this, but we need to more budget to achieve this monitoring and evaluation for many years. Community engagement and stakeholder involvement is this part is totally match of sustained goals, I think. Community awareness programs, participatory workshops, collaborative decision makers. We need to improve all these all this section. Also, you can see my colleague Özkan's project also, and the right side, the top of the right side, and the other colleagues the field survey to detect some tolerated plant in the south area. This is important, and this is very different project also performed Turkish government by Turkish government. It's extra information also. The Turkish government produced natural gas storage area under the Salt Lake, about 1.5 kilometers underground, and pumped the fresh water under the Salt Lake and create a big hole about 1 kilometer diameter, very big hole, and created 9 hole. Storage capacity is around 10 billion cubic meters. It's very huge. Started 9 years ago. So started to storage natural gas also. This is just information. I think it's a very unique project by Turkish government. Yes, thank you.
Thank you very much for this insightful presentation from Turkey. Very good to see it. We have a time for one very short question. If there is one pressing question. Do I see a hand? There is a hand from... No, there is no hand. Yes, there is a hand from Mason in the first row.
Thank you. It was nice presentation, and I have a question in regards to the last slide. What is the purpose of the gas reservoir regards to the salt effect?
We need to storage natural gas. We don't produce natural gas because we need to storage. We need to storage, as you know, to use. You know, the gas, natural gas, is a very very important, very strategic energy for all countries. So we need to storage and to use some problematic situation. Yes, this is the just the governmental purpose. Yes, thank you.
Okay, great. Thank you very much again for the nice presentation and insightful information. And now we would like to invite Ms. Agnieszka Piernik from Nicolaus Copernicus University in Toruń in Poland. Ms. Piernik will tell us more about salinity shapes Salicornia europea functional traits.
Good afternoon. Good afternoon, everyone. At the beginning, I would like to thank organizers for giving me this opportunity to present our research about Salicornia. My name is Agnieszka Piernik. I represent Nicolaus Copernicus University from Toruń, located in central Poland, because many people during the lunchtime asked me where Toruń is located. So this is this dot, the place of birth of Nicolaus Copernicus. So I think it's one of the most important places in the world. Today I will talk about Salicornia functional traits. Increasing interest in Salicornia europea is due to its extreme salt tolerance and growth in marginal saline soils. It has potential economic value because it can be used as food, forage, or biofuel, and has potential in pharmaceuticals and cosmetics. The variation in Salicornia europea functional traits in response to environmental conditions still needs to be studied, because most of studies are focused on biochemical traits, while these morphological and anatomical, especially anatomical, are not well described yet. Because we are here in an international group, I would like to stress that plant functional traits reflect life strategies and determine how plants respond to environmental conditions. So the first step is to recognize the pattern of changes in functional traits, and then to find processes behind these changes. So here we are at the first stage. To fill gap in the existing knowledge about functional traits, the changes, the variability of functional traits of Salicornia, we focused on addressing how functional traits from different scales of salicornia organization are controlled by salinity level. We put two hypotheses. First, that salinity affects plant morphological and anatomical and physiological responses in different ways. And second, that plant trait responses can indicate optimum growth in the salinity gradient. We performed pot experiment. Seeds for this experiment were collected in halophyte nature reserve in central Poland under relevant permit. Salicornia germinated seedlings were planted in substrates saturated to the total capacity in 5 salinity treatments, 0, 200, 400, 800, and 1000 millimolar natrium chloride solution. Plants were grown for 60 days in a growth chamber under controlled environment and irrigated by distillated water and Hoagland solution once a week and once every 2 weeks, respectively. To assess morphological and anatomical traits, we use novel image analysis method. We use a software ImageJ program. Growth performance was assessed based on morphological traits and anatomical traits. We also included biochemical traits that covered photosynthetic pigments, soluble protein content, hydrogen peroxide, and proline content, and catalyze and peroxidase activity. Results were compared by one-way ANOVA with 2K post-hoc comparisons between treatments. Differences based on the whole set of traits were generalized by non-metric multidimensional scaling with the Bray-Curtis similarity measure. And we also selected the most affected traits by salinity by discriminant analysis. Going to the results and focusing on growth responses and the morphological traits, we find that plant height, number of branches, plant surface area, and shoot diameter were limited significantly at 1000 salt solution. Also, plant surface area was lower at 0 and 200, significantly lower than in 400 and 800 millimolar natrium chloride. Biomass was also limited by salinity level, was significantly lower at 0 and over 400 millimolar. We consider shoot fresh and dry weight and root fresh and dry weight. And the same we find what we consider the total biomass below and above ground. Coming to the anatomical responses, we found that cells were affected by salinity. So in general, cells were smaller under stress. We found that they were smaller at 0 and 1000 millimolar in terms of cell area, cell perimeter, and cell diameter. We also found that cell roundness was the smallest and 0. Control treatment and aspect ratio, which tell us about sphericity of cells, were lower, expressed as aspect ratio was lower at 400, 800, and 1000, what means that cells were more spherical than in 0 and 200 millimolar. Coming to the biochemical traits, we find that chlorophyll A, B, carotenoids were the highest at 0, so without salinity, although the biomass was significantly smaller than in 200 and 400 millimolar. Proteins were limited over 400, so at 800 and 1000. Oxidative stress was significantly the highest in 1000, expressed by hydrogen dioxide, and was managed by peroxidase activity, which was significantly higher at 800 and 1000. Proline, we didn't find the significant increase in proline along the together with increasing salinity. Comparing all traits together, we found that growth optimum can be set for this Salicornia population can be set between 200 and 800 millimolar natrium chloride in terms of soil salinity between 20 to 40 decisiemens per meter. And was denoted by morphological biomass and anatomical traits. The selection of the most affected traits told us that the most affected was chlorophyll A content, carotenoids, plant surface area, protein content. Each of them explain about 1/4 of the variability between treatments. And also significantly, when explaining less variability, were affected peroxidase activity, number of branches, aspect ratio, responsible related to severity, and cell perimeters. So number of branches, plant surface area, and cell perimeters were significantly higher between 200 and 400, while the highest carotenoids, protein, chlorophyll A contents at 0, and cells were less spherical at 0, and under high salinity, 800 and 1000 millimolar, significantly higher were peroxidized. There was peroxidase activity. So coming to the conclusions, we confirm our first hypothesis that almost all functional traits were salinity dependent, and but they were influenced by salinity in a different way. The most affected traits include photosynthetic pigments, protein content, plant surface area, peroxidase activity, and anatomic characteristic related to the cell shape. Morphological, biomass, and anatomical properties indicated optimum growth between 200 and 400. And in this way, we confirm our second hypothesis, that is the optimum is possible to set based on functional traits. And growth limitation we noted at 0, 800, and 1000 millimolar. We did not find statistically significant relationship between proline levels and increasing salinity, which was not expected based on the reported findings regarding glycophytic species. And our results significantly expand the knowledge about Salicornia functional traits, especially these anatomical, about the variation in the salinity gradient, which can be important for discovering in the next step these regulating processes and in the next step for possible agricultural applications. More details you can find, because these results have been published already in journal Plants, so you can find it. More details you can find in this article. And in our other papers related to Salicornia functional traits, considering also cell wall nanomechanics, and in papers in which we prove that response to salinity of Salicornia is dependent on the population. So the maternal salinity and probably also by microbiome, but this microbiome is the topic of my colleagues presenting poster today. So thank you very much for the attention.
Thank you very much, Agnieszka, for shedding some light on Salicornia functional traits. Very interesting as well. Again, looking at the time, we have a time only for a very short question and a very short answer. Let me see. Okay, I think Jose was first, Pepe was first. So Pepe, please go ahead. Short question. Let me help. Thanks a lot.
Okay, congratulations for the speech. Just one question, because you analyze hydrogen peroxide and some hydrogen peroxide scavenging enzyme like catalase and peroxidase. But you know, catalase is very restricted to the peroxisome. Did you analyze other H2O2 scavenging enzyme like ascorbac peroxidase? Could be interesting also, because ascorbac peroxidase is more distributed in different organelles.
Because I'm ecologist, not biochemist, so it was ascorbate peroxidase.
Okay. No, okay. With the data, it's the same that the photorespiration could be induced because during the photorespiration, H2O2 is produced a lot, and because of catalase decrease, you know, this H2O2 is produced in the peroxisome. It's saying that the H2O2 can be out of the peroxisome and induce an oxidative stress, probably in the cytosol, probably. But it could be interesting to analyze other enzymes related with the reactive oxygen species, because with only catalase and peroxidase, this is an imbalance. You know, I think it could be better if you can measure all the enzymes related with reactive oxygen species scavenging. Okay.
This was, thank you very much. This was just general overview of the traits, and some of them are together with genetical responses. The relation of the some gene expressions are still in the progress.
Great, thank you very much. I believe we can continue this discussion in the coffee break. And now I would like to invite Mr. Francisco Perez Alfosea from Sebasi, Spain, to tell us more about hormonal responses to combined phosphorus deficiency and salinity in soybean. In the meantime, I will set up your presentation.
Good afternoon, everybody. I would like to thank the organizer for giving me this opportunity to tell you about our research today in this post-action. I have to say that we usually work with tomato, but today I'm going to tell you about some results that have been obtained in soybean under low phosphorus and salinity and its combination.
Because it's a bit, yeah.
Yes,
now it's
this work was indeed carried out by one of my PhD students, Puri Martinez Melgarejo, working at the University of the South of China in Guangzhou, under the supervision of Professor Jian Tian, and also in collaboration with the Professor Ian Dodd from the University of Lancaster in the frame of a bilateral European-Chinese project. Well, about the crop, everybody knows about the importance of soybean. It's one of the most important crop field in the world. And China is particularly interested in this crop because even if it's not the most producer in the world, it's a very big consumer, and indeed is one of the first importer of soybean in the world. So they have a lot of interest in increasing yield, crop yield in soybean in this country. But this is limited for one side because of the salinity of the field where soybean is grown, and in the other part is also, this area are also affected by low phosphorus availability, and you can see here. So usually coexist both stresses, salinity, and low phosphorus in the soy green field in China. So they are interested in developing salt-tolerant varieties and also high phosphorus use efficiency varieties, in this case, which is related to the different root system architecture that is able to capture more phosphorus from the soil. So, okay, so the main objective in this collaboration has been studying the physiological responses and the hormonal responses of two cultivar, soybean cultivar growing on the low phosphorus salinity, and this combination, trying to understand what is happening in those stresses, particularly in the combination, in order to improve the genotype and to improve by breeding a better management of those soil where both stresses are coexisting. So we did an experiment with two genotypes, one high phosphorus use efficiency called YCO33, and another one that is low phosphorus efficiency user is called BD2. And we cultivate under optimal condition, low phosphorus, moderate salinity imposed by 75 millimolar sodium chloride, and also under high salinity, in this case 150 molar, that resulted completely lethal for soybean, and the combination of the moderate salinity with low phosphorus and the high salinity with low phosphorus. We can see here the experiment with the combined salinity at the high salinity, low phosphorus resulted in was viable, but with high salinity alone was was lethal. So this is not new. There are some benefits from growing in this mixed combination. This is not new, but it's attracting more research in the last time. Well, this experiment, as I mentioned before, was carried out at the South University of Agricultural University of China in Guangzhou. The experimental design was applying this treatment that I mentioned before for 15 days in young plant, and then at the end we took sample. We analyzed the biomass, different parameters, metabolite, hormone, and some gene expression related to ABA metabolism. First of all, we can see that the effect of the different stresses on shoot and root biomasses. I cannot use the pin pointer. Okay. Here we can see how the salinity effect is moderate salinity effect, and high salinity is higher than low phosphorus. That this affects in both varieties, but in a higher extent the more sensitive cultivar. But which is interesting is that in the combination of low phosphorus and moderate salinity, there are an increase in growth, particularly in the root system, that also happen on when the plant are cultivated only under low phosphorus condition, and this is especially occur in the more tolerant genotype. So this is related to the response of the root system architecture under those conditions. Here we can see different parameters related to the root system architecture in both genotypes. And we can see here, as in, for example, in the sensitive cultivar, there are a decrease in those parameters under low phosphorus and salinity. However, in the tolerant genotype, those traits are maintained or are even increased under those conditions, which is reflected in a more developed root system architecture that allow a better adaptation to those conditions. If we look at the accumulation of phosphorus and sodium in those plants, we can see that under salinity, there are a strong increase in phosphorus in the accumulation in the leaf, particularly in the more tolerant genotype. However, there also an increase in sodium under salinity that is higher in the most sensitive genotype. Even if under the combination of both species, there are some decrease in this toxic agent in the plant. However, under other treatment, there are almost no differences in phosphorus concentration between both genotypes. But if we analyze the phosphorus use efficiency based on the total phosphorus accumulated in the plant and the biomass produced, we can observe that there are in effect a strong higher phosphorus use efficiency in the most tolerant, the most vigorous genotype compared to the most sensitive one. If we look at different metabolite or different physiological mechanisms that could be involved in those responses, one of the main differences between both genotypes is, for example, the constitutive amount of assimilate in form of exos of sucrose in both genotypes. We can observe that the most tolerant genotype accumulate hexose, which indicate a better energetic status in this plant, while the sensitive genotype accumulate more sucrose. This is also interesting to see how under salinity, the amount of hexose in the root almost disappear in the sensitive cultivar, while it remain stable in the more tolerant cultivar. So these are some indicators that the more tolerant genotype have a better energetic status compared to the most sensitive and less vigorous plant, and this happens even under optimal conditions. If we analyze the different hormones, particularly the ABA, we can see first that there are differences in the constitutive level of this hormone between both genotypes. Is twice higher in the tolerant compared to the sensitive genotype. They remain stable both in shoot and root in the tolerant genotype, while the sensitive genotype, there are a strong increase in ABA in the leaf, in the root under salinity, which is alleviated in the root in the case of the combination of the stress with low phosphorus. So there are differences in ABA accumulation, in the ABA responses between both genotypes, and then we analyze the metabolite that the precursor of the ABA in those plants are also some of the catabolite of the ABA. And some gene expression related to the ABA catabolism. Here we can summarize, for example, in terms of ABA catabolite, that the ABA catabolite are constitutively high in the phosphorus inefficient genotype compared to the phosphorus efficient. In general, the salinity alone or combined reduce ABA precursor and induce ABA catabolism, mainly in the form of phasic acid and dihydrophasic acid, although in a higher extent in the most sensitive genotype. And the combination of the stress, moderate salinity, and low phosphorus increase the production of 8-hydroxy-ABA, while decrease the amount of phasic acid and dihydrophasic acid in root compared to salinity alone. Therefore, we can conclude here that ABA hydroxylation is differentially regulated by salinity by the combination with low phosphorus and in a different form between both genotypes. Indeed, we analyze the different genes involved in ABA catabolism in the leaf and in the root. We observe some differences between both genotypes that could explain those responses in terms of ABA. First of all, the constitutive level of these genes, expression of the gene under optimal condition is higher in the most sensitive genotype, which explains the lower level of the active hormone ABA under optimal condition. Other interesting responses are observed, for example, in the induction under salinity of some of those catabolic genes, but in a different way between both genotypes. In this case, there are an increase here in this gene, and there an elevation under salinity, under the combination with the low phosphorus. We can see the same here. However, this one is insensitive in the case of the tolerant genotype, but they are an induction under the combination of both stresses in the sensitive genotype. And overall, it means that there are a different regulation of ABA catabolism in both genotypes under salinity under the combination with low phosphorus that could help to explain the different behavior of both genotypes. Regarding our other hormone that we have also been analyzing and focusing on the differences between moderate salinity and the combination with low phosphorus, we have seen, for example, that the combination alleviates the accumulation of the ethylene precursor, which is a negative factor in regulating growth, compared to the moderate salinity alone. And also the combination of the stressing recover the level of gibberellin in the root system that will help also to explain this positive response in terms of growth under the combination of both stresses. And again, this response seems to be differentially regulated in both genotypes. Also, it's very important to mention, because this is also very new, that the most tolerant genotype accumulate melatonin. Melatonin is a hormone-like compound. It's very recent, has been recently discovered, and is receiving a lot of attention. This compound is much more accumulated in response to phosphorus and more intensely under the combination with salinity, but only in the most tolerant genotype. So it's another indicator of this genotype in response to these stresses. So as a conclusion, we can say that salinity promotes phosphorus uptake, but this is not clear that this is very useful, because this high amount of phosphate accumulating the leaf is not interesting, can be even toxic for the plant if it is not converted in biomass. But in fact, there are a strong increase in phosphorus acquisition and the salinity condition that doesn't happen in the other condition. The combination, the moderate salinity and low phosphorus also reduce the ethylene production and the leaf accumulation of isopentenyl adenine. Isopentenyl adenine is related to communication between the shoot and the root, that is also involved in inducing root responses to some stress starvation in the area part of the leaf. This is also attenuated under the combination of the stresses. And as I mentioned before, the recovery of the gibberellin levels in the root. Also about melatonin, that is being revealing as an important compound involved in the response to the stress by protecting the leaf, or even by promoting the root development because of this putative auxinic effect. The higher constitutive level of ABA coincide with the greater vigor and more extended root system in the absence of stress and low phosphorus, while high salinity alone or combined the strong accumulation of ABA and the metabolite and the special level of ABA gene are related to an increased sensitivity to the stress. The differential constitutive ABA level may condition the soybean responses to the stress, which seem to depend on ABA catabolism. Finally, the combination of the stress also alter in a genotype-dependent way the ABA trace, particularly the ABA oxidation, explaining some of the genotypic responses to stress, which deserve further investigation. Thanks to all the contributors to this particular work. This is Yuri Martinez, and this is the Professor Jian Tian working at the South University of China. And this was done in the frame of the SURE bilateral project. That's it. Thank you very much. Do you have any questions?
Thank you very much. I see a strong team behind this research. This is great to see. We're running a little bit late, so one sentence question, one sentence answer. if there's one. I see Ahmed with a question.
Yes, thank you for nice presentation. I would like to ask if you use one salt for expressing the salinity. So if you use a mixture of salts, so the street will be different. Can you imagine? Thank you.
It's a good question, but I cannot answer you at this moment because I have no idea. I don't know. It doesn't seem to be a sodium specific in this case because there was no differences there was no difference in sodium accumulation. So maybe it's also related to the osmotic pressure and that could explain the higher amount of phosphorus that have been staked under those conditions. But I cannot explain to you. It could be interesting because in fact in the soil there are not only sodium chloride, and most of the time there is not sodium chloride the problem. So it's interesting. But as I mentioned before, this observation about the benefit of the combination of the stresses is quite new, so it deserves more investigation. It's interesting. It's okay?
Fantastic. Thank you very much, Francisco. Thank you for being here with us. And now I would like to invite Ms. Giulia Azzurri from the National Research Council of Italy, Institute of Sustainable Plant Protection. And Giulia will today tell us more about the insights on how the halophyte Tetragonia tetragonides deals with saline environments. Giulia, welcome to the meeting. The floor is yours.
Thank you very much, Kate. Can you hear me well with this? I prefer to that one. Okay. Good afternoon to everyone. So thank you for the introduction. It's better? As you want. I prefer this. Okay. Thanks. So yes, this afternoon I would like to talk about some insights on how these halophyte Tetragonia tetragonioides deal with the salt in saline environments. Yes. Okay. Before starting, I would just like to share some consideration on the context. So we are all aware of the nexus between water and food production, which are very much tightly together. And we are facing some major challenges today that can become disrupting factors for food security, which include for sure population growth, which is forecast to reach 9.5 billion people by 2050. And which is growing together with the effects of climate change, because those two are growing together with a very negative impact on the natural resources, which are on the basis of the food production that we were talking about at the very beginning. So the situation is quite complex, and focusing in particular on the water resource. Actually, when we talk about water scarcity, we are talking about fresh water scarcity because of water itself. We have quite a lot on the planet, but for the 97%, this is saline water, and we can't use it very much in the food production system. Also because, for example, just 6 crops cover more than the 60% of the total global agricultural production, and they do all belong to the salt-sensitive types of crops. Also, the area of the salinized soil is about 1 million square kilometers, and every year further 1.5 million hectares is also furtherly lost due to salinization. So probably our current farming system should try to adapt to the new situation. And to give some suggestion, I would like to introduce this group of plants, which are called halophytes and are salt-tolerant plants that can grow and reproduce up to 200 millimolar NaCl concentration. And they do adapt to such saline environments thanks to morphological, physiological, and biochemical adaptive traits. And importantly, many of those crops are edible, and they can become then crops in a saline agriculture context. So having said that, I would like to introduce the main character of the presentation of today, which is Tetragonia tetragonioides, one of those edible halophytes belonging to the family Aizoaceae, also called the New Zealand spinach, and which is already consumed in several world areas. Regarding its salt tolerance, there are a lot of studies which has already been made, and its salt tolerance threshold was identified in a range of about 10 decisiemens per meter, but in hydroponics, even higher concentration were very well tolerated, up to 18 decisiemens per meter. And importantly, also, growth response was observed in the range of salinity that goes from 5 to 10 decisiemens, suggesting a sort of simulation derived by the presence of salt. How do these plants deal with sodium? This is the question I would like to address today, and the answer I'm going to try to provide are coming from different experiments. So let's start from this one. This is a rhizoslide experiment where we did grow this plant in this system that was developed as a two-dimensional salt substitute to monitor salt accumulation, root architecture, and transpiration rate in young plants. And the plants were grown at increasing salt concentration, starting from a control, and then 100 millimolar and 200 millimolar NaCl concentration salinity treatments. The results I'm showing now were just accepted for publication yesterday. So as you can see in the first graph, the transpiration of plants did significantly decrease at increasing saline conditions compared to the control, but nevertheless, the biomass production that you can see in the second graph instead increased, and that was possible due to the very much increased water use efficiency that this plant showed in saline conditions. The growth of the plants showed the typical halophyte curve, where a certain amount of salt did enhance its growth, and then after adding maybe too much, the curve decreases again. Here, what we tried to do, following the scheme on the right, was to collect some samples from the paper sheets, and we collected at 4 different heights and at 2 points, close from the root system and far from it. And then we extracted those paper discs and determined the concentration of sodium included. And we wanted to understand if there were differences at the same height between discs collected close to the root apparatus or far from it. And whereas in control condition, no differences or trends were assessed, in the second graph, which is the one related to the higher salinity treatment, we can see that under saline condition, the concentration of sodium in proximity of the root system was always lower compared to the one far from it, suggesting then a sort of activity of sodium uptake by this plant. Now we keep this concept in mind and we jump to another experiment. This is a pot experiment where we wanted to compare different soil conditions. We tested the plants, the tetragonia plants growing it in both clay and sandy soil. Then we also compared 2 different climatic conditions. So we performed the trial both in spring and in autumn, and the soil treatment used were the same, control 100 and 200 millimolars NaCl. The results I'm presenting are a part of a manuscript which is under preparation. And again, you can see the same growth curve. You can see it both in the graphs and in some example pictures. So growth was enhanced in sandy soil at 100 millimolar concentrations, while the 200 millimolar concentration treatment was detrimental for the growth of the plant. Here we wanted to do something similar to what we did with the paper disc of the rhizoslide experiments. And so we collected the soil both close to the root zone and far from it, and we compared the electroconductivity in the soil samples. As you can see, again, we found the same pattern with the soil samples collected close to the root zone, getting an electroconductivity lower compared to that collected far from the root zone. We did a step further and we went to analyze the concentration of sodium in the leaves, and we found significant increase in its concentration in saline conditions, both 100 and 200 treatments compared to the control. We keep again those information and we jump to the third experiment. Here we grew tetragonia plants in hydroponics, and the soil treatment used were the same. So a control 100 millimolar NaCl and 200 millimolar NaCl added to an Ogland solution. And in this case, we wanted to understand what was going on with the growth, but we also aimed at localizing the sodium in the plant tissues. And we tried to do this in two ways. So from one side, we analyzed the different plant tissues, specifically leaves and root samples for its sodium concentration using an ICP emission spectrophotometer. And also we used confocal imaging to try to detect where the sodium was localized in the plant tissues. Again, the results I'm presenting are part of a manuscript, which is under preparation. Here you can see some results regarding the growth of the plants. So you have in the first line the fresh weight, and in the second line the dried weight of entire plant, shoot, and root respectively. Again, we found an enhancement of the growth at 100 millimolar an ACL, and compared to the pot experiment, well, differently from the pot experiment, in this time the 200 millimolar proved not to be detrimental for the plant's growth. When detecting with the ICP spectrometer the ion concentration of sodium in leaves and roots, we found out a higher concentration in leaves compared to the roots. And the results obtained were comparable to that of the leaves of the pot experiments. So in both the growing methods, soil and hydroponics, the uptake activity of sodium and its translocation to shoot was comparable. Also, when analyzing the plant tissues with confocal imaging, we localized the sodium, especially in the epidermal layer, and in particular into the bladder cells and in the apoplast, meaning that the plant keep it away as far as possible from metabolically active tissue, not to damage its growth and physiology. Bladder cells, you can see it a bit better here. So those are the some modification that you can find on the leaves of several halophytes, including Tetragonia. And here we went to detect the size and density of those bladders. And we found out that at both salinity treatments, those bladders resulted in bigger diameter compared to the ones of the control. And at 200 millimolar, also they resulted in higher density. Do I still have a few minutes? Maybe.
We have a few, but let's try to wrap up also.
Very well. Very quickly, because I know my colleague Julia Mozzo already presented you something about this. The point of those last slides was just to say that the accumulation of salt in the leaves did not seem to affect the perception of consumers of the plants, which is also quite an important point of view since we are talking about edible plants. And to the question how salty it is, the sample that we interviewed of 125 people, for its half answered just about right. And for the other half was very variable, suggesting a sort of subjectiveness of this parameter. So to conclude, Tetragonia shows a remarkable potential for being cultivated as a crop in a saline agricultural context. And the appreciation showed by people was very interesting. And also we found out that both local producers and also companies are starting producing and selling these species. And its salt uptake activities, which did not affect negatively the perception and appreciation of people, has instead an important role for phytodesalination, because the salt that is uptaken from the soil, it's taken to the plant, then taken off from the soil, which was freed from it. Thank you very much. If you have questions.
Thank you very much, Julia. Always good to hear more about the Tetragonia and our main character. The last question before the coffee break, very short one as well. Any pressing question to Julia? Oh, it doesn't look like a halophyte.
It doesn't look like halophyte. What do you mean? Because it looks more like, yeah, it has white leaves, very comfortable to be studied with gas exchange instrument compared to Salicornia. I'm sorry. No, well, actually, it has some, well, it looks like a leafy vegetable. But when you go detecting the morphological adaptation, you can see, for example, a very easy increase of succulents and other morphological adaptation, which are quite typical to halophytes. Nevertheless, I was impressed by 2 presentations ago where you tested the Salicornia up to 100 millimolar. You see my higher salinity treatment was 200 millimolars. So of course, between among halophytes, there are very much different degrees of salt tolerance. And with this, we can reach maximum 200, not more than this.
I see one more very short question.
Your experiment with the rhizosphere, would you recommend it to all people studying saline crops? And do you know of other experiments going on in the same way? What's your view on the use of this technology?
So for us, and by us, I mean the partners of the Salad project, which was the project in the frame of which we developed these experiments. That was very useful, and it went together with other experiments in a chain, starting from that specific setup in under controlled conditions, moving then to the greenhouse, and then moving to the field. So alone, it won't tell you the whole story, but to start to understand it will tell you a lot. So yes, of course, I recommend it. And if someone is interested, it's kind of a tricky setup, so please reach out, because we had multiple problems that we solved, and we can share the progress to start from a easier way.
Thank you very much, Julia. Let's continue this discussion during the coffee break that is coming now. Let's reconnect 4:45, so 4:45. And yes, the coffee break is coming.
Go ahead. I think you need
Gradient. Ma'am, can I continue?
Yeah, go on. Sorry.
Okay. So the experiment was conducted with the IPNS, that is Integrated Plant Nutrient Supply System, to also find out the optimum level of fertilizer for the brinjal crop. So before going for the test crop, the field was divided into 3 split. That is, the first one is the exhaustive crop, to create the variation or heterogeneity in the same field. So 3 strip was formulated, one with the control and another with single dose. Then second one is the double the dose of the fertilizer. Then after the harvest of the crop, the test crop, brinjal crop, was raised. Here the nomogram was developed based on the equations. So based on this, the nutrient requirement was calculated. The contribution from soil, contribution from fertilizer, and contribution from organic manure, all the things are taken care to give the fertilizer recommendation. Here the contribution from soil is more in the case of nitrogen, followed by phosphorus and potassium. Then after seeing this, for targeting yield, here I have fixed target is 280 to 290, 300 quintals per hectare based on the available yield data obtained from the experiment. For example, if it is applied with, suppose our soil test value is 200 kg maize. If it is added with 12.5 tons of farmyard manure, how much we are applying? Or if it is added with 25 tons of farmyard manure, how we are applying the fertilizer? Suppose if the farmer doesn't having any organic manure, straight away he can go for the, that is fertilizer, that is NPK alone, through the, that is fertilizers, urea and SSP and MOP. So the nomogram was developed.
Amal, please wrap up in 1 second.
Okay. So the conclusion of this my experiment is application of NPK plus organic manure, that is saving the fertilizer dose. It will also take care of the soil health apart from the farmer's additional income. Thank you, ma'am. Thank you so much.
Thank you so much. So now we quickly go to the next speaker, Sofia Bacacci. She's here online. Let me see. Sophia, now you can unmute yourself and start presenting.
Okay. Hello, everyone. Did you hear me?
Yes, yes.
Yeah, okay. Thank you for opportunity to talk about our research. This area we are working on, focusing on Europe, Hungary. It's the study area is about 50 square kilometer salt affected plain, which is a protected plain close to the Danube, situated in the Danube Valley. And because of different reasons, I mean studies and teaching and different research, there are some places in this protected area which are described as their soil type and different other properties. And we decided to revisit all these sites, which was described in the 1964 at first, and in 1979 to determine the differences we can find. Based on the legacy maps, we could fix the soil profile sites, and we revisited. You can see two profiles on the poster, which were in the lower part. Yes, on the left there was a Solonchak Solonets in the first description. According to the first description, it was Solonchak Solonets, and now we found these are Meadow Solonat soils now, and another one which was a alkaline Solonchak soil turned into the Solonchak Solonets. In both profiles, we can find some changes. The weakening of surface and near surface salt accumulation, and an increase in the Meadow Solonat soil formation processes. In some cases, the changes were observed in subtypes or soil type level, but according to the drilled holes and water analysis, there was no trend in the total dissolved salinity of the groundwater was observed over the study area. But the truth is that the observed groundwater level was deeper than in 13 years ago. The water table in the large central part of the study area was typically half meter lower than before now, so it's lower than before. So we think that because the changing meteorological conditions, the frost-free surface over the last decade, in addition to the low evapotranspiration in winter, is likely to favor water uptake and further surface outwash in the region. So this desalinization process is detectable in this region. Thank you very much for your attention.
Thank you, Sophia. So I invite Igor Bogunovich. He's here. If you want, you can manage yourself. So that if you want, you can manage yourself. Okay. So you can take it. Yeah, so you can make it zoom out, zoom in, zoom out. But hello, 2 minutes, 2 minutes.
Only 2 minutes? Okay, I will try it. Hello, everyone. I'm Igor, coming from University of Zagreb in Croatia. And behind me...
elindultál már? Nem, még itt vagyok. Na, most végeztem. Na.
Not mine. Stop this talk. Okay, we will continue now. Okay, behind me you can see one experimental research that we do in Mediterranean part of Croatia. This area was abandoned agriculture, abandoned land for at least 3 decades, and my friend from college have that land in long-term lease. So we go over there to help him to see what are the limitations and advantages of these soils. And after the mapping, we noticed that significant limitation in salinity and sodicity, because these are boulder type area. It's below sea level of 2 meters in Croatia. So the seawater intrusion makes some significant damage to soil system. And after that, we established experiments with 2 tillage systems, and inside each we add soil conditioners and different amendments, sulfur, gypsum, and gypsum with organic farm manure in different quantities. And we ran for the experiment 4 years. So we have a lot of data. Of course, we use only part of the data to present here. And what we can see that when we comparing the tillage systems, we use the shallow tillage disc harrowing, and comparing with also the same system with ripping in one pass combined tool, and we can see that ripping with shallow tillage improve soil water capacity and significantly reduce the soil compaction status of these soils. So the bulk density and penetration resistance was significantly lower. And when we look for stability of the aggregates are higher also on the tillage system with ripping and this harrowing, comparing to shallow tillage, but this is only not significant. When we use and directly compare the amendments, we can see that amendments also have positive impact on soil properties. Amendments increased combination of gypsum and sulfur have a significantly higher soil water content in addition to control, while penetration resistance show average higher 10 seconds. So these 2 minutes are very, very short. Okay, on the end. Okay, to conclude. Okay, for each farmer, the yields are the most important at the beginning. There are no difference in yields. And what is the worst? We have 2 short period between application of sulfur in addition to before sowing. So sulfur decrease the yields, but after 4 years, we have significantly higher yields of culture and deeper tillage and under soil switch soil amendments compared to control. So for more data, which we have a lot of them, it's much better to continue after the break if someone have any question. Thank you.
Thank you. So yes, you can realize that we are very short in time. We have 30 speakers, so I'm sorry to be tough. Yeah, let's continue with the next speaker. What is it? What is it? Acceptar? What shall I accept? I don't know. Okay, so yeah, I will open the presentation and share it with others. Mhm.
Well, while they are trying to do some science, I inform you. We are enough people for the gala dinner. Okay, then we reach 40, and I think I ran to I ran to the restaurant and they exit. Not me. Because at 5 they go out. Everything. Okay, we wasn't that much, but we are gala dinner tomorrow. We gotta be somewhere.
Okay, yes.
So hello everyone. I'll be talking about the endophytic diversity in Salicornia europea. Endophytes are quite interesting group of microbes because to be an endophyte, they need to enter the plant. So during the entry, they need to fight the climate which is outside first, which filters in the soil. Then they need to enter the plant and fight the mechanisms inside the plant. But once they establish, they kind of live inside the plant, forming a mutualistic interaction. So I would like to start with my poster on the diversity of Salicornia europea. I isolated endophytes from Salicornia europea that was growing in 2 sites in Poland, both different in terms of their salinization history. If you see this table here, the site 1 is a natural site which has higher sodium present, whereas site 2 is the anthropogenically saline site, which showed more calcium. This is actually a soda factory over here in site 2. And I wanted to check what exactly could affect the endophytic diversity inside the plant. So besides selecting 2 different sites based on salinization history, I also checked the stage, the growth stage of the plant, which is when the plant is almost germinating in spring and when it is mature in fall. So 2 growth stages. And the third factor was how does the endophyte spread inside the plant, whether it is more in the shoot or root. In case of Salicornia, they are hyperaccumulators. So most of the salt is actually present in the shoot. So in my study, if you see, this is the CCA plot right here, and B and D are the NMDS plot. I found that the endophytic microbiome in the plant was clearly divided, significantly divided based on the plant organ, that is shoot and root. And then secondly, also the site, the effect of salinization history in the site kind of divided the community present in the plant. And also when you talk about the diversity of bacteria and fungi, thinking they are endophytes, they should be protected inside the plant from the changing salinity. But it was not true because I realized that the shoot had lesser community of both bacteria and fungi compared to the roots. The roots showed more diversity. One of the reasons was because, as I already said, Salicornia europea is a hyperaccumulator. So there's more salt on the shoots. So that could be one of the things that could filter the microbiome diversity. Secondly, to be an endophyte, most of the microbes, they come from the soil. They're vertically transmitted. During the transmission, they change metabolically to benefit the plant. So the metabolic changes inside the plant, most of the microbes, they start producing a lot of phytohormones, which is very beneficial for plant growth in adverse environments. So to prove this, I did a second objective where I isolated the microbes on growth media, and I inoculated them in a glycophyte plant called Lolium perenne. And I chose 2 different fungi, and I did the length, the dry weight, and the proline and chlorophyll analysis. And I found that compared to my control plants in 3 different salinity treatments, the endophyte treatments were beneficial for the plant growth, especially in a glycophyte under salt stress. So this kind of gives a picture of what this fungi may be doing in Salicornia europea. And we can say that most of the isolates that I isolated from this plant were all halotolerant, which also tells us that based on the environment inside the plant, the microbes also change. Thank you.
Thank you so much. So we go to the next presenter very, very quickly. Who is Julia? Julia is here or not? Let me see if she's there. But we don't have. Georgia.
I just dropped here. We will be at 9 o'clock. Okay? I just passed to everybody and they can.
Okay, then we move to Irashmi. So I think that is here. Yes. Then
Hello.
yes, so you're welcome.
Yes, ma'am. So, ma'am, you will be sharing the poster, no? Or should I share?
No, I will share. Wait a moment.
Okay.
Okay, you're welcome.
Okay. Good evening, everybody. I'll be talking on the soybean and mustard cropping system, which we had grown on the sodic soils of Western India. And the purpose for selection of this crop is that mostly the marginal farmers of this area grows this oilseed cropping system in the area. However, this area has got a very high evapotranspiration, and the poor quality of irrigation water which they have used has resulted in the development of higher sodicity, of higher exchangeable sodium percentage. So here our aim was to select the soil amendments which was easily available with the region, like we have taken gypsum, farmyard manure, and the crop residue which was available for the farmers. So in this case, what we have done is that the gypsum which we have taken, we have gone for only 50% of the gypsum requirement of the soil. And for the farmyard manure, which is commonly available with the farmers, we have taken at the rate of 10 tons per hectare. And the crop residue was also taken as an amendment. So for example, in case of soybean crop, we took a mustard crop residue and vice versa for the next crop. So here we had in total 8 treatments we have planned both for soybean and mustard. However, gypsum was only applied for the soybean to see the effect. So after 5 years of experiment, what we could find is that with the application of these amendments, that is where we have applied the gypsum and crop residue and the FIM, we could find a significant improvement in the case of soybean yield, and which was followed by the mustard yield. And this contribution was mainly towards the decrease in the sodium content, and the exchangeable sodium percentage, which was initially 17%, was reduced by almost 31% from almost 11%. However, we could also find an improvement in other properties and soil quality parameters, which we actually determined with the changes in physical, chemical, and biological properties over a time. We could find that the combined application of amendment along with the recommended dose of the fertilizer could significantly improve the soil quality over the period as compared to the control, as well as the plots where only fertilizer was applied. So we could come to a conclusion that the application of 50% of gypsum requirement along with the availability of the organic amendment, whether it was FIM or crop residue, could significantly reduce the exchangeable sodium percentage and could improve or sustain the oilseed yield in case of the sodic soils of Western India. Thank you so much.
Thank you so much to be in time. Thank you. And we go to next speaker. Before. Which one? The one that you already. Georgia. Yeah, sorry. Let me stop sharing. What we need to find. Yeah, that one. Okay, can you zoom? Okay.
Okay, good morning, everybody. I'm Giorgia Guardilli from University of Florence. And in our study, we try to understand the combined effect of salt and UVB on Chenopodium quinoa. We grow seedling with 0 or 200 millimolars of sodium chloride and under photosynthetic active radiation or par light supplemented with UVB. UVB exposure modulated the metabolism of quinoa toward an increase of the hydroxycinnamic acid compound that absorbed UVB radiation. While on the other side, salinity, quinoa under salinity condition show an improvement of the uptake of potassium that was also the main player of the osmotic adjustment inside the leaf. While on the other hand, the sodium inside the leaf was still maintaining with a low concentration. Looking at the ion allocation between inside the leaf, we can see that in salt condition alone, so not with the UVB, potassium were accumulated inside the epidermal bladder cells, while in the presence of both salt and UV, the potassium concentration in the leaf and the epidermal bladder cells was quite dissimilar. Associated to this, we can see that in the combined stress, the leaf-water relation was significantly improved, and also the photosynthetic efficiency was improved compared to the salt alone. So in conclusion, we can see that light quality is a very important parameter to take into account when we are looking for the plant response to salt. And in that case, with this condition, UVB lead to a better response to salt condition. Thank you.
Thank you so much. Also very, very much in time. Go to next speaker, who will be Taimaya Ibrahim. So I would like to tell Mr. So from Cherki Golam, they're in the Zoom. So I will try to copy your presentation and will show you later. It was no access available, so I could not download it. So now I'll try to do it again. So next speaker will be Miss Ibrahim. So be ready. Looking for you. I'm looking for you. Okay. Yes, you're welcome. Can you hear us?
Good afternoon.
Yes, okay.
Can you hear me?
Yes, yes. Go on.
Thank you. Greetings, everyone. I hope you are doing well. I'm Tima Ibrahim from Syria. I'm a professor assistant at Al-Bath University. I'm happy today to participate with you in this conference. My participation under the title Reclamation Saline Soil by Municipal Salt was composed. As we know, saline soil is widespread in the world, and one of the ways to reclaim it using municipal salt was compost. We had an experiment at Isfahan University of Technology in Iran at saline soil. We used different irrigation salinity levels and were mixed soil with municipal salt was compost. The results were studied on electrical conductivity and showed that there was non-significant difference between municipal salt waste treatments and control, and that could be due to the high EC value in their original soil and municipal salt waste compost. On other hand, effects municipal salt waste compost on field capacity was positive, and these effects on the water retention might be due to a high pore size distribution of the natural materials. a clear nearly twofold increase in the sodium adsorption ratio, or SAR, value under applied saline irrigation water was observed. This is due to the increasing concentration of sodium cation in saline water. However, the amount of SCR showed a significant difference between control and municipal solid waste compost treatments. We can say as a conclusion that irrigation water salinity had a negative influence on ECFC and SCR, whereas application of municipal solid waste compost had a positive effect and it can help in the reclamation of saline soil. Thank you very much.
Okay, thank you. So, I'm sorry that I was trying to download another presentation. So, what is it? I don't know. Let's continue with our next presentation. Who will be? It will be Muhammad Imran. I think that he is here. Okay, good.
Hi. Before she is loading, if you are working with salinity in nutrient solution experiments, that's very important to focus.
Yeah,
and we know that we use usually iron EDTA and zinc, manganese, copper as sulfates. So I will like to show you what impact it could have if you are working with salinity. Let it get clear. Yeah.
Yeah, you are welcome.
So simply just look into the plant growth. If you're using EDTA together with zinc, manganese, and copper.
Let me help you. It's here. So you just then show your parts.
So time is really limited. It's like a TikTok.
Yes.
So let's try to do it. In these graphs, you see here, for example, if you use, we take sodium bicarbonate as a salinity, alkalinity increasing level. So if you use EDTA and zinc, manganese, and copper as sulfates, you have low phosphorus at pH around 7.8. And if you use all as a chelated, where you get all as anions, then you have improved phosphorus and iron availability. The most important thing is here. For example, we have nutrient solution. We know that students usually change after a week. And if you are using EDTA and sodium bicarbonate as a salinity given or alkalinity to improve increase pH, within 24 hours, your solution will start getting precipitating. After 3 days and after 6 days. If you are using DDPA as iron source, which is even more stronger chelating agent, you get still quite high precipitation within 24 hours. What is the implication? This is another type of iron. Maybe some people are aware of EDDHA or HBED iron source. It's red in color. But in fact, it's here. If you are having 5 millimolar sodium bicarbonate salinity, with EDTA, you lose your iron up to 50% within 24 hours. And phosphorus, you will also lose more than 50%. And if you are going even to very high pH, about 8, then you have no phosphorus available in the plant, in the nutrient solution within 24 hours. So we have really limited time. We also make, it's a big talk. We also use a model to see why this is happening, that iron is converted into different soluble forms of anions, and phosphorus is being precipitated very quickly with changing pH if iron source is not correct. We also use SCM-PDX to see precipitation, and you see we get almost more than 10% phosphorus when we are using EDTA. So I'm sorry, time is really limited. We can spend hours on this topic, but if you are working with salinity and not using correct source of iron, you are actually studying effect of salinity on micronutrient availability rather than physiology of plants. So that's a really key message here. So choose your iron source and other micronutrient sources very carefully. And I'm available for tomorrow. If there is any question, I'm very happy to support. And if you need chelated micronutrient samples for your research, please do ask and don't hesitate. Thank you.
Okay, thank you. Thank you. We continue. Yes, Leila, you're welcome. Yes, you can. Here is bottom. Here, yes. Mhm.
Good afternoon, everyone. I'm Leila. I'm doing postdoc in Aarhus University in Denmark. And okay, again. Good afternoon, everyone. I'm Leila. I'm doing postdoc in Aarhus University in Denmark. Today, I'm going to talk about work that we did during my PhD thesis. It was about monitoring seasonal dynamic of soil salinity in pistachio orchard field in central part of Iran. Pistachio is one of the most strategical plant for cultivating in the saline agriculture. It is because of its commercial value and of course high tolerance to the salt, but we should consider that it can accelerate degradation of soil and water. During this work, we went to the field 3 times. Okay, maybe. In 3 campaign our year, it was after dry season, after wet season, and of course after harvest. The results showed that the dominant ions in the study area was mostly sodium and chloride, and ion movement in salinity profile was related to the particle size distribution, gravel percentage, and of course it follows precipitation, irrigation, and also high evapotranspiration in the study area. Totally, mean average of EC was 43. That is really far from the suitable electrical conductivity for cultivating pistachio, which is 8. And it caused to decrease crop yield almost 50% over 20 years ago. And in conclusion, so in conclusion, in a study area, it is true that farmers still have a crop yield, but we should consider soil and water degradation. And it seems that if we reconsider the current land use and stop changing land use from reg land to agricultural use, we can maybe stop soil and water degradation. If you are interested for more information, you can have a look on the paper that we published last year, and also I'm around to reach out. Yeah.
Right. Thank you. Thank you. So now we go to the presentation of Chikri Goulam. I will try to open it. It is Borhim. So, Mr. Borhim, you're welcome to talk.
Hello, can you hear me?
Yes, yes, go on.
Thank you so much for having me. I will be presenting this poster on behalf of Mr. Chikri Goulam. I'm very excited to share our recent finding on enhancing salt stress tolerance in quinoa crop, a crop of immense socioeconomic importance. As you all know, salinity stress is a major challenge, especially in agricultural domain, severely limiting plant growth and crop yield. Therefore, our study aims to improve quinoa's resilience to salt stress using the combination of the biostimulation and soil amendments. So we worked with 2 quinoa varieties, as you can see in the methodology part, the Pinot and Ikba Q5, which are grown in greenhouse conditions. The soil was mixed with either phosphogypsum or livestock manure. And for each one, we added 5 biostimulants. And after 40 days from sowing, we applied these biostimulants every week during 4 weeks in total. And we kept one test, of course, with the amendments only, and another with no treatment, called the negative control, and also stress, and another positive control with no treatment as well, and with no stress. The results actually were remarkable, especially in the combination of sodium metasilicate with phosphogypsum, which significantly boosted the dry biomass over 240% for both varieties. The potassium content also increased by 285% for Pinot variety. The calcium content increased by 290% for ICVA Q5 variety. And also, we had a significant decrease of sodium content by more than 60% for both varieties compared to the unstressed and the untreated control. In essence, our finding indicated that using soil amendments in combination with the biostimulants can greatly improve quinoa tolerance. This approach not only promoted the plant growth and the biomass, but also improved its nutritional value while reducing as well the toxic ions like sodium, the excess of sodium absorption, etc. Thank you so much for your attention.
Thank you, thank you. So we will kind of go on. So let's see. I'm not sure that if he's here. Let's see. Okay.
The gala dinner will be tomorrow at 9 o'clock.
9 o'clock?
9 o'clock.
What? Are you here with us?
I can hear. Can you hear me?
Yes, yes.
Yeah.
Wait a moment.
Okay. Hello everyone, my name is Fuat. I am from Turkey. I will talk about now.
Fuat, can you speak a bit louder because the noise, the voice is low.
Okay.
What?
Yeah, I'm here.
Yeah, but your voice is very low.
Very low. Yeah, can you hear me?
Yes, now much better. Yes.
Yeah. Hello everyone, my name is Fuat from Turkey. I will talk about now remote sensing based and electroconductivity mapping in cropland areas. It is well known current status of soil salinity in croplands and insightful assessments for the future are urgent necessities in the Mediterranean biogeography. We well known as a proxy of salinity, the electrical conductivity of a solution or a mixture of soil and water in the different electrical conductivity ratio. We well known previously, especially in salinity mapping studies in using remote sensing. In this, it was estimated that areas with bare salt cover in the coastal lakes or different areas, salinity occurs naturally, contain high salt content. The potential of remote sensing data for spatial estimation of soil electrical conductivity, it is well understood, but are some difficulties in croplands. Therefore, exploratory analysis of soil electrical conductivity and remote sensed in this off-point observation in different soil electrical conductivity levels. In this study, in this direction, we investigated the potential of low electrical conductivity and high electrical conductivity values and remote sensing data such as Sentinel-2A provided by ESA. And which widely used for salinity mapping in the agriculture areas, Italian croplands. We were used salinity index and normalized different vegetation and different index, and also in this area we used the 628 sampling points in croplands. 8 samples were found above 0.75 dcc mass meter, potentially indicating early signal of salinization state of threshold by FAO, and this area. Actually, in the area, the remaining in the salinity bit index, April and soil electrical conductivity values above the correlation coefficient negative 0.69. And then also, while no significant statistical relationships was found between NDVI and NDCI in this and soil EC low values than 0.75 decimeters.
Conclusions, please.
Okay, I finish it. In line with deepen understanding of soil electrical conductivity level mapping approach and conduct exploratory analysis involving soil science by the identify environmental variables to be included the modeling, particularly in the especially in croplands highly sensitive to influence of human environment. The focus should be development of new environmental variables that comprehensively characterize information of salinity relationships. Thank you for attention.
Dear thoughts, thank you. We quickly go on. So the next presenter will be Nizamuddin Mamutov. So I cannot. Nizamuddin, so if you are here, raise your hand in Zoom. No. Then we go to the next. Then we go to the next presentation of Mr. Martin Ho. Are you here? Okay. We present from here.
Hello, everyone. It's a nice pleasure to be here with you. Congratulations for the organization, the FAO and the project Sustain and the University of Valencia. My presentation is about is a preliminary about preliminary results from the work done, the activities done in the working group 5 of Sustain project related with the policy salinization. The idea of this working group is to collect information. For now, in the first steps, is to collect information from the local organizations in each country of members of the project. And in my case, I tried to collect information from the Portuguese organization, and it was not easy to collect this information. So I take here some insights. but in fact, it's not easy because the Portuguese organization seem to be more concerned with the water scarcity than with the soil salinization, because it's not so visible as the water scarcity. So in any case, there are some opinions about the soil salinization, and namely, and the soil salinization, and my focus is about policy salinization. And the idea is, in general, the policies and the legislation, Portuguese, national, and European, is not adjusted to the problem. And the most important problem identified by these stakeholders was the way as the problem is identified, and the way as the process are monitoring, and the way as the information is collected, including by international database like Lucas. So there are some doubts about this way, about the ways as this information is collected, because in general, namely the national approach are old and traditional, and maybe not adjusted to give a good outputs about the problem of salinization. In any case, this is, as I said in the beginning, these are preliminary insights, outputs, but I think we have here some ideas to continue, and for the next meetings with in this case, the Portuguese stakeholders. So.
Yeah, thank you so much.
You.
Thank you. Yeah. Dear colleagues, actually, we have quite exceptional situation. I mean that previously when we had oral poster sessions, it was 50% participation, but today we have almost 100% participation. So we have quite a tough agenda for today. So we will be a bit late. Let's go to the next speaker, who will be Mr. Mustafa Marzi. Let me try to find him. Yes, it's here. And Marzi. Okay. Mustafa, you're welcome. Mustafa? It seems that his sound doesn't work. Mustafa, you are unmuted, but we cannot hear you. It seems that you have some problems with the sound. Okay, try to connect through the different device, and we will return to you after the next presentation, okay?
Can you hear me now?
Now we can hear you, yes.
Okay, good. So I can continue to work.
Okay.
Yeah, I think you can hear me now.
The sound is quite a bit.
My name is Mustafa Marzi. I'm gonna present a project entitled Estimation of Saturated Soil Phase Electrical Conductivity and Soluble Salt from extract of different soil to water extract, namely 1:1, 1:2.5, and 1:5 in some non-gypsiferous soils. So to do this project, we gather 64 samples from the arid and semi-arid regions of Iran. And we do the sample preparation and measure the physiochemical properties of soils and determine their
relationship between the ECA 1 to 1 and ECA 1 to 2.5 and ECA 1 to 5. And use different tests, including root mean square error, mean absolute error, and deviation from 1 to 1 to test the accuracy of the relationship between these two parameters. Based on the results, we find the best relationship between the ECA 1 to 1 and ECA of saturation extract. And as shown in figure 1, the conversion factor between these two parameters was almost 2. And also in the moderate texture chart, which is shown in figure 2, the conversion factor was 2.33. And also in all the soils, regardless of the soil texture, the conversion factor was 2.28, which is shown in figure 3. And also between the soluble salt and soluble cation and anions, which is shown in table 1 in light color, in light blue, there was some reliable conversion factor between the extract of saturated extract and extract of 1-to-1 ratios. So in conclusion, the literal conductivity of saturated extract and also soluble salt can be estimated with an acceptable accuracy from ECA 1 to 1 when it is multiplied by almost 2, and therefore it is recommended. Thank you for your attention.
Thank you, Mustafa. Thank you. We go on to Primitiva. Your presentation is next.
Okay, thank you very much. Yeah, I'm going to share with you today about the review that we have done since 1990 to 2024 about farmers' coping strategies to manage salt-affected soils for sustainable rice farming in the face of climate change in Tanzania. You can agree with me that rice, it feeds about 50% of the global, and this is a potential crop that we need to put in sustainable ways so that we can be able to produce the crop. Yes, so from the methodology, we use the PRISMA, that is the preferred reporting items for system reviews and meta-analysis that guided us the systematic peer review of the literature. And then going to the results that we got from the review, we found that farmers in Tanzania, they use different coping strategies when it comes to management of salt-affected soils. And these are reaching, that is thrashing farms. They plant drought-tolerant varieties, as well as salt-tolerant varieties. They plant maturing rice varieties so that they can be able now to cope with the high evapotranspiration rate that are within the farm. In rice farms, they use rice husks, as well as some they use biochar. And we found that there are integration of more than one management. Yeah, for example, the most used, there is the integration of inorganic fertilizer with the farmyard manure. That has been, we found that it has been able to reduce the salinity. And in conclusion, some of the strategies that the farmers are being used in Tanzania, when it comes to climate change, you can see there are some of the practices or management that will not be sustainable. So we need now to look on more strategies due to the available resources And we need to make sure that the farmers, they will be able to hone these management practices that we are going to, or we are working on it. Nowadays, in Tanzania, there is a big project that has been funded by NIDA and a climate lice projects that we are trying to map the salt extent in Tanzania, and we are breeding the varieties of rice that will be able to tolerate the salt. Thank you very much for listening.
Thank you, Primitiva. Let's go on. So next presentation will be from Veronika Mistrikova.
Time is running, so I will fast. So my name is Veronika Mistrikova. I'm from the Institute of Plant Genetics and Biotechnology in Slovakia. As the title said, the aim of our work is to screen promising new collections of genetic resources of grain Amaranthus species for salinity tolerance. We choose the grain amaranth because of their potential as important pseudo-cereals. We selected fine amaranth varieties, namely Amaranthus cruentus, which is a original genotype Ficha, and the Slovak cultivated variety Pribina, our Slovak cultivated variety, and then a commercial variety Pleisman, which is Amaranthus hypochondriacus cross Amaranthus hybridus, K433 variety, and again a Slovak cultivated variety Zobor, which was generated at our institute. In our preliminary experiments, we tested the germination rate of these selected varieties at 3 different concentrations of salts. As you can see, the Zobor has the highest percentage of germination at 200 millimolar salt concentration, salt stress, followed by the variety K433. Interestingly, the original genotype Ficha for Pribina was the most sensitive variety. Then we simultaneously made some morphological parameters of 4 weeks plants, which were treated again with salt stress for 5 days. We measured the total plant length, root length, shoot length, and also some leaf parameters. As you can see, the length of the plants was not so significantly affected, also between the individual control and salt-treated plants, and also between the individual varieties. And what we have observed was that also, for example, the number of vital leaves was not changed dramatically. But when we measured the salt tolerance indexes for these selected parameters, for example, we have observed that the Zobor again has the, for example, highest tolerance to those tested stresses, and related to the selected leaf parameters, the number of vital leaves, for example, was not so changed dramatically. Interestingly, for us, the leaf area was also not dramatically changed. But we can say in conclusion that according to these preliminary results, the Slovak grain amaranth varieties could possess enhanced parameters for salinity tolerance. That's why we want to test the high concentration of salt stress and perform more investigations related to using, for example, the light and transmission electron microscopic analysis. So that's for that moment everything.
Here we go to next presentation.
from Giulia Mozzo. Giulia. Traponia. No, yeah. Now I will know it very much, very well.
Okay, so for the studies, we use a 2D experimental setup with two different alophytes, the Tetragonia tetragonoides, and that was grown with three different salinity level. The control 100 millimolar and 200 millimolar sodium chlorides, and with the Canopodium quinoa, the variety Redhead, that grown with two different salinity level, control and 100 millimolar. So we try to evaluate the distribution of the sodium around the root apparatus. And for this reason, we grown the plants inside a plastic bag and along the filter paper. So we try to evaluate the sodium concentration, collecting disc at different age and a different distance from the root apparatus. So we evaluate also the transpiration. So we sealing the plastic bag. So the salinity affects both the root apparatus and the transpiration that decrease significantly in the salt-treated plants. In the New Zealand spinach, we found out that the concentration of sodium around the roots was decreased, suggesting the uptake of the salt from the plants. In contrast, we found out that the concentration of sodium around the roots of the quinoa was increasing, so suggesting that was not uptaking the salt during the ground. So the New Zealand spinach accumulate the sodium and showed an increase in water use efficiency at the concentration of 100 millimolar sodium chlorides. In contrast, the quinoa proved to be less tolerant in the specific variety that was the Redhead, suggesting that its mechanism in the frame of the sodium excluder halophytes were less effective in dealing with the administrated salt treatment. Thank you.
Thank you. So next speaker will be Mr. Nieberg. He's here.
Hello, hello. Hi there. There we go.
Mhm.
My name is Yannick Nyberg, and I think today I represent the private sector. I'm part of a company called Seawater Solutions in Nara. And what we focus on is trying to scale saline agriculture from the perspective of the private sector. So we've tried it a bunch of different ways, but we do believe that carbon and biodiversity markets are the best way to finance projects, pay for capital, materials. And we believe this because there are a number of precedents and case studies where carbon markets have financed agricultural carbon projects. So what we're doing now is developing a platform tool called Saltlands Earth, where we register different projects around the world, such as from our colleagues in Pakistan, Morocco, elsewhere. And so we hope that you all have an opportunity to register your projects on this platform and begin to register those carbon credits in order to get some financing into those projects from the private sector. So please reach out at the break and later today. Thank you.
Almost 1 minute. Thank you. So next speaker, Michel Petrillo, Mr. Okay.
Okay, hello everyone. My name is Michele Petrillo and I'm a researcher at the University of Florence. And here I present to you the work that we carried out on the New Zealand spinach. You all experts on this plant by now, after all these presentations. So the work that I want to present is on, let's see here, is the work that we carried out on the pot experiments. We tested this plant to see how different combinations of soil type, climate, and salinity of irrigation water would affect the productivity of the plant. Additionally, we also investigated the ion accumulation in the leaves to better understand the adaptation to the soil stress of this particular species. So we ran 2 pot experiments, one in spring and one in autumn. And for each, we had 2 soil types. One was clayish, one was sandy. And for each soil type, we had 3 different levels of salinity, low, medium, and high. And let's see. So we found that the highest yield was reached with sandy soil and in spring. And we observed that there were statistically significant interactions between the independent variables, soil type, season, and irrigation water. We also found that the ions were accumulating in the leaves in the bladder cells. And interestingly, we saw that there was a stocking limit for sodium, and this was about 80,000 ppm. This was here. And this was reached at 10 decisiemens per meter of electrical conductivity in the soil. The salt uptake was also confirmed by the analysis at the soil level, where we saw that the electrical conductivity was inversely proportional to the root density. So in conclusion, we think that this study highlights the importance of considering the pedoclimatic conditions in combination to the irrigation salinity when growing halophytic crops. And also, we believe that our findings can be valuable for the crop modeling in the salt-affected areas. Thank you. And if you have any questions, you can come see me after the presentations.
Thank you. So, yeah, next speaker will be Mason, Mr. Rezaei.
Good afternoon. My colleagues, Dr. Hashiminejad and Dr. Jambazi told about pistachio, the economic aspects. So this work is the part of evaluation of irrigation management in orchards in Iran. We try to evaluate different orchards regarding to flood irrigation, surface drip irrigation, and subsurface drip irrigation. And we found out that subsurface drip irrigation is the better than flood irrigation regarding to the yield and water consumptions. So after that, we among the 30 orchards, we select 3. We used INSAS module in using which implemented in Hydrus 2D. And we evaluated the frequency and the amount of water which would be applied to the orchards. And we did the scenario analysis, and we found out the frequency of 15 days. And using 8 hours of the 8 hours of the duration of the irrigation would be the best for the orchards in Gazvin in Iran. Thank you so much.
Thank you, Mason. Yes, perfect timing. Yes, so let's go on. Luis Roca Perez. I don't know. It's you? Mr. Roca Perez. This is what you're on behalf of him.
He can come, and today I'm going to present his study. Or
Yeah, on
okay.
his behalf.
No,
Yeah.
because he is travel today and
This one,
he
right?
can.
Roca Perez.
Sí,
Okay.
Roca Pérez.
Okay. Okay.
Good afternoon. My name is Eva Fernandez, and as a co-author, I'm going to present this study. The application of compost in agriculture is widely used practice since it can improve soil quality. Salinity is a factor that limits their agricultural use. The objective was to study the effect of the application of a compost class B made with a rice straw, suet slab, on a basic calcareous clay loam soil dedicated to citrus cultivation, in order to evaluate the risks of salinization, alkalinization, and sodification. A field study in which 3 doses of compost, here, T1 6, T2 12, and T3 36, 10 per hectare were applied to the soil from a control. In the saturation strat, pH, electrical conductivity, carbonate, bicarbonate, chlorate, sulfate, nitrate, borate, and ion, and calcium, magnesium, sodium, and potassium cation absorption, sodium absorption ratio, and exchangeable sodium percentage were determined and monitored during 7 months. An increase in value of the all parameters analyzed was observed during the first days. In the first, where volume normalized after 28 days, and most affected parameters were electrical conductivity, sodium absorption ratio, and exchangeable sodium percentage. Increased salinity was mainly associated with nitrogen ion, calcium anion, magnesium anion, while bicarbonate, chlorate, sulfate, borate anion, and sodium cation did not substantially influence. The pH in the saturation strat did not exceed 8.5 in any case. Exchangeable sodium percentage value were always below 3%. This result indicates that the agreement with a previous study, however, if compost soil management is not done properly, the increase in soil salinity can be a limiting factor of its use in agriculture. Therefore, of the application of this compost at dose between 6 and 36 tons per hectare does not pose any risk related to soluble salt for similar soil to that of this study, and represent a viable option for the value of rice straw and suet slab, contributing to minimize the harmful effect of the health and the environment that occurs when rice straw is burned in the fields. Thank you so much.
Okay, thank you. Let's go to our next presenter, Mr. Muhammad Sabir.
Yes.
So Sabir, I cannot. Yes, but Sabir is. Mr. Muhammad Sabir, if you are in Zoom, can you raise your hand? Okay, he's not here. Then we go on with Sakib. Okay. Sakib.
Mr. Muhammad Sakib, can you hear us? Mr. Muhammad Sakib, can you hear us again? Let's check. Okay, I'm afraid that
Mr. Muhammad cannot hear us. Let me try to unmute him. Mr. Sakib? Okay, in this case, I would suggest that we move to the next presentation, and if Mr. Muhammad comes back, then hopefully we can hear his post-presentation as well. So now I would like to invite Ms. Najat Sarouk.
So hello everyone. So I'm Najat Sarkouh from Morocco. My studies is mapping and studied the Sabkha of Tazra, a known area of salt in the south of Morocco. So by remote sensing. So to better predict soil salinity, we have mapped the salinity in Sabkha Tazra, a semi-arid area, as I said, known for salt concentration in its around and its surface. So the use of soil salinity mapping is important for better predict salinity for agriculture area. It was enable us to better understand, monitor, and also predict future possible salinization risks, consequently minimizing the negative impacts of salinity in other area. So from I am bad in technology. Okay. So for the methodology, we started by a visual interpretation based on our knowledge of the studied area. So then we applied the supervised classification using the reason of interest. After that, we have adopted the method of band ratio. So the normalized difference ratio model developed by Nile at all in 2007. Yes. So the figure represents the result of the supervised classification. So we have this table shows us the different classes resulting from the supervised classification of Landsat H. Oli. So the area occupied and the area occupied and the percentage of each classes. So we have there 7 classes. So in these cards, we have the result of the normalized difference ratio model predicted the occurrence of gypsic and natric soil to monitor spatial distribution of saline soil in the Sabkha Tazra and its surrounding. So from the results, we can observe that the gypsic soil and the natric index demonstrate a great potential in localizing high level of salinity. So from the result, we can distinguish between saline zone and non-saline zone. So we can also observe that the natric index and the supervised classification has successfully detected the same area. And the gypsic and natric index present satisfying classification. This is especially true in the case of natric index. So consequently, the application of these indexes on the Landsat data proves to be very effective of Landsat data and for detecting this saline affected area is as well as differentiating the multiple levels of salinity in salt affected area. So thank you for your attention.
Thank you, Najat. We go on to the next speaker, Janina Smaoui. Your turn. So you can.
Good afternoon. My name is Janina, and I'm a researcher at the Institute of Environmental Studies at the Vrije Universiteit in Amsterdam. I'm presenting a research project that we conducted together with the Netherlands Enterprise Agency on salinity in 12 different sub-Saharan countries. The aim of this project was to understand governance challenges of salinity better by looking at the scientific knowledge that is available, impacts of salinization, policies that are in place, and 30 international initiatives that address salinization in that area. I want to present 3 key findings. First of all, Maria, how does that? Yeah, can I? This direction, okay.
Do you prefer to have it displayed on the full screen?
No, I think it's okay like that. Thank you. Yeah, when it comes to the availability of knowledge in that region, we can see that it varies strongly. Some areas, for example, the Horn of Africa or coastal areas are quite well analyzed, while some inland countries are still lacking comprehensive analysis. When it comes to impacts of salinization, we were able to identify 4 main impact categories: economic impacts, such as the loss in yields and arable land; environmental impacts, such as biodiversity loss or a reduction in water quality; social impacts, such as the threats to livelihoods and increasing of poverty; and cultural impacts, such as the need of changes in agricultural practices. Lastly, the 30 initiatives mainly focus on networking and information sharing activities, while the focus on financial support and commitment to standards is still lacking. We published a report and a policy brief based on this project, where we provide a handful of recommendations to address these challenges. So if you're further interested, you're very welcome to have a look there. Thank you.
Thank you very much, Janina. And we will now switch to the poster of Ms. Katalin Sulimosi, who will present on sodium ions that have the strongest negative impact on the chlorophyll synthesis and greening of the wheat seedlings. Let me change the screen.
Hello, can you hear me now?
Yes, we can hear you very well. Please go ahead, Katalin.
Hi. Dear audience, thanks for the possibility to present our data carried out mostly at the Eötvös Loránd University in Hungary. The topic is about wheat germination, because under agricultural conditions, depending on the soil and the cultivar, wheat seeds are sown at 5 to 10 centimeter depth in the soil. Thus, in the beginning of their development, the seedlings and their leaves develop in complete darkness within the soil, cannot produce chlorophylls, are therefore yellowish in color, and develop ethioplasts instead of chloroplasts. However, upon reaching the soil surface and sunlight, chlorophyll is synthesized, the plants turn green, and ethioplasts get transformed into chloroplasts, photosynthesis starts, and seedlings switch to autotrophy and survive and grow further. However, in the soil, not much data have been produced about how the leaves, which are directly exposed to soil salinity, salinity are affected by different salts. And this was the aim of our investigation, to study how greening was affected by various salt concentrations and ions. In model experiments, we pre-treated the leaves with various solutions and then greened them on these solutions and observed how fast the chlorophyll protein complexes of the photosynthetic apparatus and the photosynthetic activity developed in them, and how fast their ethioplasts transformed into chloroplasts. What we found is that osmotic stress as well as low concentrations, well, relatively low concentrations, so 300 millimolar potassium chloride did not influence the greening process. Various solutions resulted in partial inhibition of the greening, and the solutions which contained high concentrations, so 600 millimolar sodium in various forms, sodium chloride, sodium nitrate, or even a mixture of potassium chloride and sodium chloride, induced a peculiar swelling of the ethioplast protylocade membranes and resulted in full inhibition of the ethioplast to chloroplast transformation. So these salts are the most detrimental on the greening of the seedlings. Thank you for your attention.
Thank you very much, Katalin. And now we would like to invite Mr. Foday Suma from Sierra Leone Agriculture Research Institute to tell us more about characterization of mangrove swamp rice soils along the Great Scaris River in Sierra Leone using principal component analysis. Let me find the presentation. Okay. Okay, Mr. Foday Sumar, please, the floor is yours. Let me try again to unmute.
Hello.
Yes, we can hear you.
Hello. Okay.
Please go ahead.
Although I'm having some difficulty with internet connectivity. Yeah. Thank you for having me. I'm Foday Suma from Sierra Leone. So I'm presenting this poster, characterization of mangrove swamp rice soils along the Great Scaris River in Sierra Leone. You hearing me?
Yes,
Hello.
we can hear you very well. Yes, yes, please go ahead.
Okay. So this study was as a result of the difficulties we're experiencing as a result of this global warming and climate change effects. The mangrove swamp ecology in Sierra Leone is one of the 5 main agroecologies we have, and it is the only ecology that is subjected under this salinity through seawater intrusion. So we have salinity as in figure 1, wherein you see the area where we collected our samples based on a scale of 1:10,000. That is 100 meters by 100 meters area, we collected sample. So within the 11 spots, you will see along the Great Scaris River, on these farmlands, we collected these samples and did our analysis. The analyzed samples, we analyzed samples for both physical and chemical analysis. Physical, we did for organic, we did for sand, silt, and clay, all these particles. And as well, we did for the chemical, pH, organic carbon, and all others. As in figure 1, I just mentioned, wherein we have these sites. So we subjected, after analysis, subjected all these samples to the statistical package of the principal components analysis, so that we'll be able to study the wide variation that may involve in them. Because interpreting them after analysis is very difficult, because we dealt with large number of samples. So that's why we included the multivariate tool, which is principal component analysis, to analyze them, so I'll be able to see the variation within them. In table 2, you see the rotated matrix using this principal component, wherein it is said that when we have eigenvalues greater than 1, we take them for granted. So we normally use them to predict our samples. For eigenvalues less than 1, normally reject them because their percentages in terms of the loadings, they are very low. So those with higher values, we normally take them for analysis and for interpretation of results. Like for instance, for the silt, the mechanical analysis for silt component, we have 83%. So there is a wider variation with all the samples from the upper stream to downstream towards the main source of the Atlantic Ocean, where we have our silent seawater. Likewise, other parameters study. Then on the distribution for particle size analysis also, we notice that there is a wide variation, especially in terms of silt components, which in the principal component analysis also showed us 83%. So there is also a wider variation in that. Likewise, other parameters, exchangeable sodium and exchangeable potassium are very high, and they range from upstream to downstream, which is very closer to the Atlantic Ocean, where is the source of the salinity we have in Sierra Leone. So for the results, we gathered results. The gathered results show that these soils are highly saline, especially during the dry period, unlike the raining period, wherein most cropping is done as a result of the low content of the salinity. But because we are having this migration and people are leaving their farmlands as a result of this climate change effects, so these farmlands are being abandoned, and most of their crops are sometimes failed as a result of the lowering the periods of cropping, because salinity will just intrude into the farmlands when maybe the crop is almost at its reproduction stage. So also what we realized, the soil samples all around these areas are highly acidic in nature, and it was confirmed on another analysis to be acid sulfate soils, which demands a high or robust management practices for them to be managed for sustainable crop production. I thank you very much.
Thank you very much. I would like to now invite Mr. Pier Vellinga from the Vrije Universiteit in Amsterdam, from the Netherlands, to tell us more about saline agriculture, climate funds, and impact investors.
Yes, glad to be here. My name is Pier Vellinga, and I participated in the EU-sponsored SALAD project on upscaling saline agriculture worldwide. And for upscaling, of course, we now recognize that under certain conditions and practices, you can commercially grow crops on saline areas, but it's only in small plots so far. So an upscaling would indeed require the involvement of government policies and funding. And we had a workshop in Brussels where we invited the World Bank and major climate funds to discuss the issue. And we found that they increasingly recognize it, but it's not yet full on the agenda. The World Bank, for example, has a window for climate smart agriculture that includes putting carbon capturing in the soil, as one of the previous speakers mentioned. And other climate funds are, of course, ready to finance climate adaptation. But for them to do so, it's very important that governments have in their national adaptation plans that they report under the climate regime this whole issue as a problem and as a potential beneficiary of climate adaptation funding. So with this SALAD project, we try to mobilize and synthesize the major funds in the world. They start to recognize it, but there is still a way to go. And a conclusion is that, well, governments will have to put it on the agenda. And in the end, microfinance organizations are better equipped to do that than the big funds like the World Bank. But even microfinance organizations do ask such a high return on investments that it doesn't work for farmers or farmers organizations. So in the whole financial sector, there is still a mismatch between our needs and development country needs for funding and what they can offer. And through our project, we hope to work on it. And through your governments, you can work on it as well. That's my conclusion. Thank you.
Thank you very much, Pierre. Now I would like to invite Ms. Ludmila Worontynseva from National Scientific Center, Institute for Soil Science and Agrochemistry Research, named after Solokovsky from Ukraine. She will tell us more about integrated soil and water management under saline conditions in Ukraine. Ms. Worontynseva, the floor is yours. Let me also load the presentation. Yes, can you please check if you can? Yes, great. Please go ahead. The floor is yours.
My name is Ludmila Worontynseva, Institute for Soil Science and Agrochemistry Research, named after Sokolovsky. To ensure the sustainable development of salt-affected soils in Ukraine, the application of the principles of integrated management of soil and water resources is relevant. The basis of the concept of integrated management is the management of soil and water for socio-economic development and preservation of ecosystems. To ensure the integrated management of water and soil resources, it is necessary to apply conceptual approaches to the regulation of reclamation lots. The result of salt-affected soils regulation is the regulation of the system ameliorative lot soil. Regulation of meliorated lots should be aimed achieves the maximum social ecological effect and minimization negative changes from anthropogenic impact on soils. In Ukraine, the resolution of the Cabinet of Ministers of Ukraine on standards for environmentally safe irrigation, irrigation and drainage management approved standards for environmentally safe irrigation and irrigation management. We have developed the concept of regulation of meliorative loads on the soil cover of irrigated lands. Thank you.
Fantastic. Thank you very much, Ludmila. Now we turn to Ms. Katia Witzel, who will tell us more about the potential of selected wild plant species as crops on poor soils, and she represents Leibniz Institute of Vegetable and Ornamental Crops in Germany. Please welcome, and let me also put on your presentation.
Yes.
Yes.
Thank you very much. So I'm going to present two projects that are currently started in our institute. And the main idea behind is to use wild plant species that have interesting properties, like medicinal properties, or they accumulate interesting compounds, to use them to grow on poor soils. And the aim of the project is to create new value chains in regions of Germany which were previously been used for coal mining. So this has been stopped now, and they are looking for new ideas to create some value in these regions. And the plant species that we are interested now is, they are shown here, Pimpinella saxifraga and Oenothera biennis. Both have interesting properties. One is accumulating antimicrobial compounds, so it could be used as, for example, biofumigation of soil salinization, also, and the other one, Unotera, is accumulating interesting fatty acids in seeds, which is used in the pharmaceutical industry and also in skincare. And what you see here is that we have now started, or maybe this, started some analysis of these physiological characteristics of those plants in drought stress and salt stress experiments, and also using those in compacted soil stress experiments. And at the moment, we are characterizing these plant species to give some recommendations to potential growers and farmers in those regions in Germany. Thank you.
Fantastic. Thank you very much. Now we would like to invite Mr. Tugrul Yakupoglu from Yozgat Bozok University to tell us more about the salt-affected soils in Turkey. Let me also put on the presentation. Yeah, it's loading. Yeah.
Hello everyone, my name is Tuğrul Yakupoğlu. I am from Yozgat Bozok University in Turkey. Before start, I would like to thank Sustain leader for invitation. Yes, topic of my poster is salt-affected soils in Turkey. As an agricultural country, Turkey has salinity problem in 1.5 million hectare. In total, in total, 74% of barren lands are saline, and so on. Figure, you can see Turkish map of principal soil types in Turkey. Yellow colors represent calcium soils. I select two plain. I selected two plain for the work because the first one, the first plane is important for the sugar beet cultivation, and the second plane is important for the grape cultivation for vineyards. In this study, salinization in two important agricultural areas in Turkey, Konya Basin and Iğdır Plain is described. The largest area affected by salt in Turkey is located in the Konya Basin. A significant part of the soils in this basin are soils formed under the influence of saline groundwater. In this basin, where there are lake source and temporary puddles, sodium chloride and sodium sulfate, as well as calcium and magnesium salts accumulate on the soil surface and forms saline soils, solonchaks. Yes, and the second one. Soil salinity in the Iğdır Plain. Second plain is Iğdır. Another region in the Turkey with salt-affected soil is the Iğdır Plain. The availability of land use in agriculture is limited, and the main problem are inefficiency, stoniness, high slope, salinity, overgrazing in pastures, water and wind erosion, misuse, short growing period due to the cold and continental climate. You can see some values of the EC, soil organic matter, and exchangeable sodium percentage. As a conclusion, in addition to these two areas, salinization problem have started, especially in the soils of the southern Anatolia region, where irrigated agriculture has been introduced, and in the plain of the Mediterranean, Aegean, and Marmara regions, where intensive agricultural activities are carried out. These areas are of vital importance for Turkish agriculture due to their production capacity. In addition, seawater intrusion is also an issue that needs to be considered when researching salinization of coastal plains. Thank you.
Thank you. So, colleagues, we have 4 more participants who are a bit late with their posters, but still, let's give them 10 minutes in total. So 4 speakers. The next will be Miss Aska Salim. Let me find her first. Not see her. I cannot see her. Then Nuray. Nuray is here or? Okay. You're welcome. You want another mode?
Yes. Nice, thank you. Hello, I am Nuray Çiçek. I am from Çankırı Karatekin University. We have some experiment. You can see we use the organic fertilizer in figure 1, bed guano, seaweed, manure, and vermicompost. And you can see other pictures, plant space experiment in the studies. In figure 3, the effect of seaweed of scientific condition lavender growing, our experiment name. In this experiment, we used control group 0.5, 1, 2, and 4 liter per decar seaweed, and we used sodium chloride concentration 0 control 40, 80, and 120. In this study, some morphological, anatomical, physical, and chemical properties we experiment and plant nutrient element analysis were performed. According to the result of the analysis, it was found that salt stress adversely affect lavender grower and seaweed application significantly increased the parameter experiment. We also conducted different trial with other organic fertilizer and plant space. Organic fertilizer, particularly seaweed, bed guano, and liquid vermicompost have considerably and significantly impact plant growth, quality, and nutrient uptake under substrate condition. In conclusions, organic fertilizer hold great potential for elevating substrates and recovering the salt effect soil. The integration of the organic materials with convectivity fertilizer has been proceeded as a sustainability approach of the managing salt effect soil, further embracing the potential of organic fertilizer in this context. Therefore, studies are needed to optimize their application for different plant species and soil conditions. Sustainability management practice supported by effective policies are essential for ensure and long-time providedly and environmental sustainability of soil effect soil. Thank you.
Thank you, Nuray. Thank you. So let's go next, Mr. Prasada Rao Kongala. Let's see. He's here. Which one? Let's try this. Mr. Prasada, please try.
Yeah. Hello, everyone. Good evening.
Can you unmute your second device? Because we can hear the echo.
Thank you, Maria. This time, can I
Yes.
share my poster? Yeah. Hello, everyone. Here I present the topic elevation of salt-affected soils using plant growth promoting rhizobacteria and its agricultural perspectives and crop responses. In this regard, my work goes in two parts. One is to isolate and identify the salt-tolerant rhizobacteria that caters that supports the rhizospheric activity of the crop plants under salt-affected soils. Secondly, the how these rhizobacteria assist the seedlings or crop plants in mitigating the the lessening of the salt effect on the rhizosphere activity. So these two objectives, keeping this, we have isolated over 1300 plus rhizobacteria from the pigeon pea rhizosphere, and they were screened for the salt tolerance. And out of that, we have selected the 7 of them based on the special characteristics such as the polyhydroxy butyrates, and these are the aliphatic uh, polyesters. They get accumulated during the nutrient limitations and the carbon excess conditions. These bacteria is specially assist under these salt affected conditions, these seedlings. So this is my first report. No other papers reports have come in this regard, though these polyhydroxy butyrates contain or accumulating bacteria explored for the biodegradable plastics, but we have experimented to help how in affected agroecologies these bacteria would help in assisting the crop plant. So we have experimented with the rice crop. So we have taken the CSR 36 as a locally grown variety, and so at 5% of the NaCl induced salinity was given along with these bacteria what we have isolated from the pigeon pea rhizosphere. And finally what we found, so it enhanced the vigor of the rice seedlings, and also seminal root numbers, and biomass in comparison with the control. So that seems to be assisting the seedlings in alleviating or in mitigating the salinity effect on the rhizosphere activity. So therefore, in the food grain production, so such
Mr. Konkala, can you wrap up in
lands
10 seconds?
Can be achieved through by assisting these special characteristics like polyhydroxy butyric contain producing rhizobacteria for the alleviation of this salt stress on the rhizosphere activity. So thank you. This is my presentation. Thank you.
Thank you. So we have 2 presentations left. Mr. Sakib. So I hope that you could fix your sound. Okay. Let me open your presentation. Mhm. Can you try to speak? No, we cannot hear you. Okay, let us give you another try. I will give a floor to Fozia, and then we will try again with you. Fozia?
Hello.
Yes, we can hear you. Fozia, we can hear you.
Yeah, Maria, I can hear.
Yes,
I'm
we can
audible
hear
to you
you.
all.
Yes, go on.
Okay. Thank you very much, Maria, in INSAS page for inviting me for presenting the impact of different salinity levels on the growth of wild rice to improve soil health. I'm Fozia Memon, and currently I'm working as a soil scientist in the Research Institute of Soil and Environment, Agriculture Research in Tandujam, Pakistan. My study was taken on the account of one of the project from the World Bank with Sindh government. We did actually using the wild rice variety very first time in the Pakistan, and it is from the nutritional purpose. I did too much nutrition from the food security point of view, and the next is this variety was amazingly introduced during our studies. We conducted a study at the Soil and Reclamation Research Institute, Tandojam, where we prepared from the normal saline irrigation water to irrigate the treatments. We prepared 8 treatments where starting from the 500 ppm sodium chloride 1 molar solution to 32,000 ppm molar solution, in which we recorded that the root and shoot length of boiled rice maximum performed at the 8,000 ppm of sodium chloride solution of 1 molar. So drastically, we can imagine that this is wild rice is magically account for the saline soils in the Pakistan, most probably for the coastal areas in Pakistan, where we need it is in abundant shapes. Plant observations were also concluded as of sodium and potassium levels, where we find a very sufficient level there, because this wild rice species has a very genetically and biophysically, it has a very important aspect is their trichomes, the hair and thread on the roots can convert the sodium into the specialization of the sufficient level. So it is variably study was conducted and come through the conclusion. This study concluded to have more impact on the soil health through soil porosity, soil texture, soil variability, and in terms of aeration, soil erosion, where this was a farmer-based study. So we recommend all the other advanced studies to use this wild rice variety for the nutritional purpose. And during the summer season, where the Pakistan has account increased by 1 to 2 degree, the centigrade temperature increased by year, and the salinity also increased, and land degradation take place from 2 to 5% every year. So we scientists concluded that sufficient varieties, salt-resistant varieties, are the solution for the farmers to account for the better livelihood and their good life health. Thank you very much, Maria.
Thank you, Fozia. So let's try with Sakib again. Let's hope that it works now. He's here. So Muhammad, try again with your sound. Hello. Sorry, Muhammad, but we cannot hear you. You are unmuted, but there is no sound in the room. Okay, so it's we are finished for today. We had a very we are well done. It was a hard day, but we gave the floor to everyone to present their results. I think that it was interesting and productive day for all of you. I think that we have a couple of announcements. First of all, that tomorrow the Sustain group will continue in the same room. So you will be coming to here. And Artemi, for the INSAS meeting, technical meeting. Yeah, for Sustain. Yeah, that's enough. So I think that we will write on the table the room of the number so that people can easily find it. Yeah. Okay, so and another announcement that let's go to take a photo. I think that we can take it somewhere on the stair, maybe on this stair. Where is better to take a photo? Yeah, near the entrance. So we can take the roll up there and take a photo. So let's go to take a photo and see you tomorrow at 9 a.m.